In order to install Postgres, we should open our browser and type PostgreSQL. And then we should go to the official link, which is this, and go to the downloads section. And now we should choose our operating system. In our case, we are using Windows, so we should press on it. And then we should press on this link, download the installer. As you can see, we have a couple of versions here, but we are looking to get the Windows version, so we should press on this. Let's wait a couple of seconds for the download to finish, and then we can press on it. And we will start our installation process. Let's press next. So here we have the installation directory, which is where Postgres will be installed. Then we can press next again. We should select all of those. Those things are necessary. Here is the path where Postgres will store all its data, the data which is related to our databases, all the tables, and all the data itself. We can press next again. Now we should specify a password. I will just call it Postgres and Postgres again. Now, this is the default port. We should leave it like this. Make sure that you specify a password which you remember. Otherwise, it can be a bit challenging to restore the password or change it after skipping this step. So let's do next. And also, of course, keep the port the same as you see here. It is quite good. It is the standard. Okay, we can do next, next, and next. And here we should wait for it to finish. The download is finished. Now you can press finish. And here you can close it. It is not necessary at the moment. And now we are finally ready to use Postgres. So the first thing that I am looking to do is to go inside the Postgres directory. So I will go into program files and look for PostgreSQL. And I will go inside of the bin directory. And here I will search for this file, which is the psql, which is the Postgres shell. It allows us to execute SQL commands inside of Postgres. And then we can create a shortcut. And then we can drag it to our desktop. When we click on the psql shortcut, it will ask us to specify a password for a different user. But here in our case, we are going to use the default Postgres user, which is just Postgres. So in order that I will be able to connect with the previous password, which is Postgres, I should log in into the Postgres user. But here, if I will type Postgres and then do enter, it will not work. So I should go to the properties, and then I should add a flag here, and then specify Postgres. It will allow us to log in directly to the Postgres username. Okay, and now we should specify the password, and I will specify the same password as before, which is Postgres. And as you can see, we logged in. Postgres also comes with a UI client, which in our case is pgAdmin. We can use pgAdmin in order to have a nice GUI interface, which will allow us to interact with Postgres. We can click here, and it will prompt us to enter our password. So our password, as I mentioned before, is just Postgres, and you should press save password so that you will not have to enter it each time you connect. And as you can see, we logged in. Now we can go here and take a look at all those things. We can, for example, press on the tables and go to the query tool. And here we can, for example, query data from our tables and much more, execute simple SQL commands, and so on. Let's walk through the Postgres shell. In order to display the databases, you can do /l. It will display all the databases. In order to connect to a certain database, you can do /c and specify the name of the database. Let's connect to the Postgres database, which is the default one. And as you can see, I am connected to it. In order to display the tables inside the database, we can do /dt. And currently we don't have any tables. In order to create a database, we can write create database and specify the database name. We will call it guide and make sure to end each command with a semicolon, otherwise it will not work properly. And now let's view our databases again. And we can connect to our guide database. And as you can see, we are connected. We can clean our terminal by doing this, CLS. Whenever we write this, it allows us to write any kind of command which is not related to Postgres. For example, I can write a dir and it will display all the directories and so on. So we can write commands which are not native to Postgres, but which are native to our operating system. And this command will work also in CMD outside of our Postgres shell. Using the Postgres shell is good, but sometimes we should use a GUI, which will allow us to write queries in a much more comfortable way. We can, for example, use pgAdmin, which is the official GUI for Postgres. We can press on the servers section. And here, as you can see, we have our database, which we just created. We can press on it, right click, and go to the query tool. And here we can start writing our queries. If you want, you can change your theme. You can go to File and press on Preferences, and then scroll down. And you can press on User Interface, which is under this, and then change the theme. For example, let's try to use dark, and we can press save. If you want to increase the zoom, you can press Ctrl, Shift, and plus. And if you want to decrease it, you can press Ctrl and minus. As you can see, the text is quite small. You can also increase the font by going into Preferences and going under the Query Tool section. And let's press on this, on Editor, and then we can change it from 1 to 3. Let's try to type now. And as you can see, it looks much more better. With that being said, we are ready to use pgAdmin. Let's create a new database which will store our to-dos. So we can do create database, and I will call it Todos DB. Let's open pgAdmin, and then we will create our first table inside of this database. We can go under servers, and then we will have all of our databases. Let's choose the database we want, which in our case is the Todos DB. We can right click on it, and then we can press the query tool. Here we can start writing our SQL queries. In order to create a table in SQL, we should write the following sentence. So we can do create table, and then we will specify the table's name. In our case, the name is to-dos. This table will store all of our to-dos, and then we should open brackets. And inside of those brackets, we can specify the columns we want and their types. Okay, so the first column I want to have is an ID. I want that each to-do will have its own ID, and then the type is going to be serial primary key. All what it does, this line, it makes sure that whenever we generate a new to-do, this to-do gets its own ID, and that we don't have to deliberately specify an ID when creating to-dos. So when I am going to create a new to-do, this line makes sure that this to-do will get its own ID automatically without me having to deliberately specify it. The second column I would love to have is title. Each to-do will have its own title. So this is the name of our second column, and the data type is going to be text. And also I can add a constraint, so I can do not null. So this column cannot be null. As you can see, on the left side we have our column names, and on the right side we have our data types. Let's add our last column, which is going to be a description, and the data type is going to be text as well. Text is a general data type which is good for storing strings. Now we can execute this command and it will create a table. So let's select it and press here, execute script. You can also press F5 if you want. And it seems like everything went well. We can go back to our Postgres shell and do /dt. And as you can see, here is our new table. And we can do select all from Todos. And currently we don't have any data. In order to insert data into our to-dos table, we should write the following query: insert into, and then specify the table's name. So in our case, the table is to-dos. And then we should specify the columns we want to insert data into. So here we want to insert data into title and description. And now we will specify the values we are looking to insert. So the first value I am going to insert under title is going to be learn SQL. And the value I am going to insert under description is going to be I would love to learn SQL. Suppose we need to close it with a semicolon. And let's try to execute it now. And as you can see, this is our response, and it means that we managed to successfully insert data into our table. Let's try to insert one more, learn backend, and we can modify it to I would love to learn backend development. We will just call it dev. Okay, and I will execute it again. And now let's do select all from Todos. And as you can see, here we have our data. In order to update a certain entity, I should write the following query, update, and then I will specify the table I am looking to update. In our case, the table is the to-dos table, update to-dos. Under that, I will specify the column I am looking to update. I would love to update the title column. And here we will store the updated value. So I will change it to modified to-do. If we will execute it now as is, all the titles will get changed into modified to-do. I am not looking to do that. I want to only update a specific to-do. So let's take to-do number 7. I can do where ID is equivalent to number 7. Let's take a look at this ID. And as you can see, it got changed to modified to-do. We can also update a second column. So let's add the description column. Description, test. I will call it test. And now let's try to run it. I will change it to test as well. Let's execute the select all from to-dos again. And as you can see, here is our new updated result. In order to select all the data, we can do select all from to-dos. Let's say that we want to select only certain columns. We can do select title, for example. It will give us only the title. Let's say that we want to get the ID along with the title. We can do select title and then comma and specify our second column. And let's say that we want to add another column. We should specify a comma again and then specify our desired column. So in our case, description. Let's run it. What if we want to filter our data based off certain things? Then we can use the where clause. We can do select all from Todos, where title is equivalent to learn SQL, for example. Then we can run it. We can, of course, filter our data based off more than one field. We can do select all from Todos, where title is equivalent to learn SQL. And then we can specify the or keyword, or title is equivalent to read a book. And as you can see, here are the results. We can also use the AND keyword in order to filter our data. We can do select all from people, where city is equivalent to New York and role is equivalent to manager. Let's try to execute it. And here are the results. Only if there is a match between our requirements and the data, we will get a result. If, for example, someone has a city which is New York, but his role is not manager, and here we were looking to get the manager role, we will not get the results. So we will get only what matches in 100%. In order to delete a certain to-do, we should use the delete keyword. We can do delete from and then specify the table's name from to-dos, where ID, and here we should specify the ID which is related to the row we want to delete. In our case, we would love to delete row number 3, so let's specify ID number 3. And then, of course, close it with a semicolon, and we are ready to execute it. Let's do select all from to-dos again. Select all from to-dos. And as you can see, ID number 3 is not there. You can delete data based off other columns, not only based off IDs. You can do delete from to-dos, where title is equivalent to workout. We can use the ILIKE operator to filter data based off a certain letter sequence. Let's say that I would love to get all the names which start with Ali. So let's do select all from workers, where name, and then we should specify the ILIKE keyword, and that's the syntax. Inside of the percentages, I will specify my letter sequence. Let's run it now. And as you can see, we got our results. Using ILIKE is very nice because that it is not case sensitive. It means that we can write Ali with uppercase or with lowercase, and it will still find the data with both cases. Now I will write it with uppercase, and now with lowercase. And as you can see, we got the same results. The group by function allows us to group values together. Let's say that now we would love to see how many products under each category. In order to do that, we can use the group by function with an aggregate function. We can use the count aggregate function. So this is the function, and this function takes a column, which in our case is the category column. So we would love to count each category. So if furniture appears 2 times, it will count it as 2. if electronics appear 3 times, it will count it as 3. But we cannot use it as is. We should tell SQL that we would love to filter it per each category. So I will show you the query now. We can remove this. We can do select category, and then I will select category again here with the group by function. So we can do count and then category as amount. So here it counts the category as a new column, which is called amount, and it will give us the amount of times each category appears. And then we can do from sales, but we cannot leave it as is. We should tell SQL that we want to count per each category. So we need to do group by category. And now we will see the amount of products per each category. So as you can see, furniture has 8 products, and those are all our values. We can use other functions despite count. For example, we can use the sum aggregate function to tell us how many quantities were sold under each category. So in order to do that, I can do select category, which is our first column. And by this column, we are going to specify our group by function. And then we can select the sum function and specify our column, which is the quantity sold. Quantity sold from sales. And then I will group by the category column to see how many quantities were sold per each category. And as you can see, here is our result. We can also see the average sale amount per each category. So I can change this query and do select category and then sale amount and call the average aggregate function. And again, group by each category. Group by category. And as you can see, here are the results. You can use order by in order to sort your data based off a certain column. Let's say that I would love to get the latest to-dos first. I can do order by ID, descending order. So I will get all the latest to-dos first. Let's say that I would love to get the first to-dos first. I can do order by ascending order. Another example we can have is this. Here we have our messages table. Let's say that I would love to get the latest messages first. I can do select all from messages. Order by sent at descending order. And as you can see, here we got the latest messages first. Now I can use ascending order to get the oldest messages first. There are some cases where we might want to limit the amount of rows we get from our database. In order to do it, we can use the limit keyword. So as you can see, now we got all the data, but let's say that I would love to limit and get only 3 rows. I can do limit 3. Sometimes when you are not looking to get all the data and you need only a specified amount of rows, you should use the limit keyword, because that whenever you have millions of rows, limiting them will make sure that your read operations are much more quicker, so that whenever you interact with the database and try to read data from your table, when you are using limiting, it will make it much more quicker to get a response from the database. COALESCE will give us the first value, which is not null. Take a look at this. Here we have 2 values. The first one is null and the second one is not null. We will get the second value. Using COALESCE might be a very good solution to null values. For example, in the workers, we have 1 null value. So let's select the department column. select department from workers, and I will call the COALESCE keyword COALESCE. I will nest the department column inside. I will remove the gap here, and here I should specify the value I want to see instead of null. So if we have null, this is the value we are going to see instead. So I will call it unknown. From workers, select COALESCE from workers, and as you can see, instead of null, this is our value. We can use the case keyword in order to output something based off our data. Let's, for example, take all the workers who have more than 5 years of experience, and then we can output them as seniors. So I can do select name, and here I will start my case. So I should declare it with a case and end it with the end keyword. And inside of that, I will start writing my first case. So when years is more than 5 years, for example, then the output is going to be senior. Let's close it like this, and then I will do from workers. Let's try to execute it. And as you can see, here David is senior because that he has more than 5 years. We can add another case, so we can do when years is less than 3 years, then we can call it junior. Okay, let's try to execute it again. And as you can see, now we have one which is junior. We can finish our case statement by using the else keyword. So I will do else and then mid-level. So if someone is between 3 to 5, he will be mid-level. Let's execute it now. And as you can see, Bob and Charlie are mid-level workers. Subqueries allow us to create nested queries, and then based off those nested queries, we can do whatever we want. Take a look at this table. I have a table which is called books. Let's do select all from books. And as you can see, those are the results. And now I am going to create a query which will give me the average rating. So let's do select average and specify the rating column. Select average rating from books. And as you can see, now we will get the average rating. And now we can use this as a subquery. So I can wrap it with brackets. In order to declare it as a subquery, you should wrap it inside brackets. And then I can do select all from books where rating is greater than the result of this. Let's try to execute it. And as you can see, here are our results. Common table expression allows us to take a query and store its results inside of a temporary table. Let's say that I would love to get the average salary of this table of employees. I can do this statement. So I can do select and call the average aggregate function on the salary column. And then it will give me the average salary based off all the employees. So I can do select average salary from employees. Let's try to execute this. And now I can take the result of this query and store it inside of a table called average salary. This is a temporary table. Let's give it a name called average salary. I will specify the S keyword to declare it as a common table expression. And now I am going to open brackets and specify my query inside of them. This is our query in our case. And as you can see now, I will just do select all from average salary. It will give us the results of this query inside of a temporary table, which is called average salary. You can see here are our results. I can, for example, specify another query here. It doesn't matter what we specify, it will get inserted into our table's name, our temporary table's name. For example, I can specify numbers here. If I will just execute this line alone by itself, it will give me those 3 numbers. Now, if I will execute the whole code, it will give me the same results. Now let's go back to our previous query, which is this. And as you can see, we got the average salary. We can make our query much more interesting and useful, which will justify our use case of the common table expressions. Let's try to select again from employees. I would love to take a look at table. And now we can see all the salaries. So I would love to know which employees have a salary which is higher than the average salary in the company. So we can do it by this. So we know that the average salary is being stored within our table, which is our temporary table, which is called average salary, of course. So now let's do this. Let's do select all from employees. I will add a bit of spacing. And here I can do where salary is higher. And then I can specify a subquery, which will give me the average salary from our temporary table. So let's do it. Select all from average salary. And now I will execute our whole SQL statement. And as you can see, here are all the employees who have a salary which is higher than the average salary. Let's see all the employees who have a salary which is less than the average salary. I can change this symbol, which represents less than now. And now here are the results. When you work on your application, you can find yourself quite often interacting directly with the database with raw SQL. And as you can see, this web application is using a lot of native SQL without any ORMs, and therefore, because of that, I quite often found myself using raw SQL directly inside of the database in order to test my queries before deploying them to the application itself. In order to interact with our database in a safe way, we can use the begin statement so that if something wrong happens, we can go back and do what is called a rollback. So let's take a look at our tables. And right now, this is our main database. And those are the tables. And let's do select all from users. What if I accidentally removed all the users? So this is the query. If I do select now, if I am going to enter now, all the users will get removed. So in order to prevent such a mistake, I can do begin, and here I can do any query I want. So I can do delete from users. Now all the users will get deleted. You can see I will do select all from users, and there is none. So we got no users. But now, because this is a mistake I have made, I can do the rollback statement and just go back to the previous state. So now I will do select all from users again, and as you can see, we were able to undo our changes. What if there is a change I want to commit later? A change that was done successfully and I want to confirm. So when we do begin, later, in order to commit our change, we should do the commit statement. So after a successful change, let's do select all from users. Let's say that user with an ID of 170 is not active anymore. We can delete him. Delete from users where ID is 170. This is a successful operation, not a mistake. In order to confirm that, we should do commit, and the changes have been made. Imagine that you have two tables in your database. The first one is related to customers, while the other one is related to orders. In order to see to what customer each order belongs, we can use joins. This relationship is called one-to-many. Each customer can have multiple orders. Let's create our customers table. Create table customers. And we are going to have two columns. So the first one is going to be the ID, of course. So ID serial primary key. And the other one is going to be a name column. And the data type, of course, is going to be of a type text. And now we are ready to execute it. Let's try to insert something into our table. Insert into customers. I will specify the columns, of course, name and values. I will call it Omri. Let's do select all from customers. Here is our data, and now I will make the second table. So I will open a new SQL script so that we can see better. And I am going to create our orders table. Okay, now let's specify the columns we want. The first one is going to be an ID, of course, so that each order will have its own ID. ID serial primary key, exactly the same as before. The second one is going to be a title. So title, and the data type is going to be of a type text. Okay, and the third one is going to be price. And also here we will have text as well. And the last one is quite interesting. So here we are going to reference to our first table, which is the customers table. So the syntax is going to be like this. First of all, we should declare the name of our column. The name is going to be customer ID, and we will reference to the ID column within our customers table. So here goes the syntax. We can declare it by the following line: integer references, and we should specify the table we want to reference to. In our case, the table is customers, and also the column, which is the ID column. Okay, and it seems like we are quite ready. Let's try to run this command, and our table has been successfully created. We can verify it by selecting data from it, even though it's going to be empty currently. So let's do select all from orders. And as you can see, it is empty. Makes sense. Let's start inserting data into our table. So we can do insert into orders and specify the columns, of course. In our case, we are going to insert data into the title column along with the price column and the customer ID one as well. And here we should specify our values. So let's say that the title is, let's say that I bought a PS5 and the price is 500 USD. And the customer ID is going to be related to me, and my ID is 1. So we should specify the customer ID. And now it seems like we are quite ready. Make sure to specify here any ID which exists inside of our customers table. And in our case, this ID exists. By specifying this ID here, we declare a relationship between this certain order and this customer, which has an ID of number 1. Let's now do select all from orders so that we can see our data. So select all from orders. And as you can see, here is our entity. And now I will use join in order to combine the data from the two tables into one single table so that it will be easier for us to see the exact relationship, so that we can see what orders each customer has. We can do select name from customers. A good convention is to use the table's name first and then the column name, so that if we have different tables with same column names, we will not have a collision. and we can prevent it by specifying the exact table name. So as you can see, that's what we did here. And now I am going to specify our join, inner join. What table are we looking to join? The answer is the orders table, so we can specify it there, inner join orders, and then we should specify our columns. So we want to join the ID column from within our customers table, so we can specify it here on customers ID. And the second column is going to be the customer ID, which can be found within our orders table. So I can specify it like this here, orders and customer ID. Let's try to execute it now. Okay, and now you are only seeing the name column because this is what we were selecting. Let's select other columns, and this time we will select them from the orders table. So we can do orders title and orders price. And to me, it seems like it is quite enough. Let's execute it. And as you can see, we got our data. Here we have data from two distinct different tables at once. Imagine that you have two tables. The first one is related to students, and the other one is related to courses. We can acknowledge that each student can sign up to multiple courses, and that each course can involve multiple students. This relationship, where each student can sign up to multiple courses and each course can have multiple students enrolled, is called many-to-many. Whenever we want to declare a many-to-many relationship in SQL, a good approach is to have a junction table, which is just a table which sits in the middle and connects our two tables. This kind of table can hold data about each student and his course. It will hold each student ID and each course ID. So let's go back to here. And here you can see our tables. We have the first table, which is the students table, and then our second table, which is the courses one. And then we have our third table, which is the student courses table. In our case, this table is our junction table. This table is holding data about each student ID and each course ID, which is related to the course the student took. Take a look at our students' data. You can tell that Bob has ID number 2. And now let's take a look at our courses data. And history has ID number 3. Let's say that Bob is looking to learn history. We can specify Bob's ID, which is number 2. We can specify it under the student ID. And then we can specify the ID which is related to the history course. And in our case, the ID is number 3. So let's do it. Insert into. Let's take a look at the table's name, student courses. Okay. And now let's specify the columns. The first column is student ID, and the second one is course ID. Let me check that it is correct. Yes, it is correct. And now we should specify the values. Let's specify Bob's ID first, which is number 2, and our course ID, which is number 3. And as you can see here, it is number 3, as I said. And let's try to execute it. And it seems like everything is quite good. Let's do select all from student courses. And here we have our results. So we have the student ID here, which is Bob's ID. And then we have the course ID, which is ID number 3. This ID is related to our history course. Take a look here. History has ID number 3. Now we can use a simple join query in order to combine data from all the tables. So let's do it. We can do select all from courses. We will build our join statement step by step. So select all from courses, and then we should specify our join, inner join, and let's choose our student courses table on courses.id, and then we should specify here the course ID, course ID. Let's try to run it. And as you can see here, we have the first step of our join. Now we should also join the students table. So let's do it. Here we should specify join again, inner join students on student courses dot student ID and students.id. Let's try to run it now. And as you can see, we got all of our data at once. We can format it a bit better, so let's do it like this. Select courses.title as course title. And then the second thing we would love to select is the student name. So students.name as student name. And let's try to run it now. And as you can see, now we have our data in a much better format, and we can see what course each student took. Let's open our browser in order to download Python. We can type Python. Let's go to the official link and press here. It will download it. Let's open downloads. And then we should press right click and click on Run as Administrator. We should check those two boxes and we should press Install Now. Let's wait a couple of minutes. After that, the download is finished. We got setup was successful. We can close this. We can open CMD and just write Python. If you see this, it means that everything went good. Another thing to check is to type pip. And if you see this as well, it means that everything went good and that your installation was successful. Pip is just a package manager for Python. It allows us to download packages so that then we can use them in our projects. For example, in this course, we will use Flask for our REST API. And in order to install the Flask library, we can use pip. So we can do pip install and then specify the package name, which is Flask. Let's let it run. And then it means that we can use it in our projects. Let's install VS Code. Visual Studio Code is a lightweight, modern IDE, which is very good for Python. So we can type VS Code. Let's go to the download section. Let's choose our current operating system, which is Windows. Once the download is ready, we can press on it. Let's press OK. And here we can press next, next again. Let's check this, create a desktop icon so that we will have a shortcut. And let's wait for it to download. Once the download is finished, we can click here and then we can open it and go to the extensions section and search for Python. And let's download it. And now we are ready to use Python in VS Code. In order to start a new project in VS Code, we should create a new folder. I will call it scripts. And then I should open Visual Studio Code. Left click here. And then I will press on Open Folder. Let's go to the desktop. And I will select the scripts folder. I will press here. Here I can press right click and create a new file. Let's call it my script.py. I should end it with a .py so that I can tell the computer that this file is related to Python. Okay, and now let's try to print hello world. And in order to run our script, we can press here. Another option is to go to the terminal section, click on new terminal, and then write Python and our script name, myscript.py. In the extensions tab, you can install all kind of things. Let's say that I am looking to install a different theme for my VS Code. I can search my desired theme here. Let's press on it, and then I can press install and wait for it to download. And then once the download is ready, I can press on the theme I want. And as you can see, now my theme has been changed. In order to change to a different theme, you can press here on this gear icon and then go to the theme section, press on color theme, and then you can choose the theme you want. Another option is to search the theme you want from here and just select him. If you want to zoom in a bit, you can press Ctrl and plus. And if you want to decrease the zoom, you can press Ctrl and minus. In order to change the font, you can go to Settings and search for font size. We already have it there, but if you don't see it, you can just search font size. Let's change it from 14 to 18, for example. Okay, and now let's go back. And as you can see, our font is bigger. Another nice extension I recommend you to install is VS Code icons. It will give your files very nice looking icons. In order to check what libraries you have, you can write pip list, and it will list all the libraries you have installed. And in order to import a certain library, you can write import and then specify the name of the library you are looking to use. For example, I am looking to use the requests library. And then as you can see, I can use it, request.get, and everything is working as expected. Variables allow us to store data in the computer's memory. Let's declare a variable which is called name, and its value is going to be Omri. We can use various data types. In our case, we are currently using a string, but we can also use a Boolean value. Let's make a variable which is called status, and then we will declare a Boolean value. We can also store integers. Let's make a variable which is going to store numbers. I will call it number. Let's print all those variables together. We can print each one separated by a comma. Name, status, and number. Unlike other programming languages, in Python we don't have to explicitly tell what data type is going to belong to each variable. We can let Python infer it by itself. You can check the type of each variable by using the type keyword. As you can see, the type of our variable name is string. We can use lists in order to store data. Let's declare a list called websites. By using this symbol, we represent a list, and then we can specify our values. So the first value is going to be Facebook, for example, and the second value is going to be Google. Whenever we want to add a new value, we should add a comma and then specify our new value. And then the third value is going to be YouTube. In order to print the list, we can do print and then specify the list name, websites. Let's try to run it now. In order to access a certain entity from our list, we should specify its index. Using 0 will give us the first element. Let's try to get the second element and the third element. We can use the append keyword in order to add a new value to our list, websites.append, and then we should specify our new value, and then I will print the list again. And as you can see, we managed to insert a new entity. In order to delete a certain entity from our list, we can use the pop method and specify the index of the entity we are looking to delete. Let's say that I am looking to delete Facebook, which is the first entity. I should specify its index. In our case, the index is 0. And then I will print the list again. Unlike lists, we can also use dictionaries in order to store key-value pairs. Let's create a dictionary which will hold all of our grades, for example. We can call it grades. And let's start specifying our values. The first key-value pair we will specify is history. And its value is going to be 100, just for the example. And the second key-value pair is going to be sports. And the value is going to be 90. Okay, let's try to print it now. Print grades. Let's see its type. Print type grades. And as you can see, the data type is dictionary. In order to access a certain value from our dictionary, we should use the appropriate key. Let's say that I am looking to access the value which is related to history. I can access it by doing this, print grades, and specify the key I am looking to get data from. In our case, the key is history. Let's try to print it now. And as you can see, we got the value, which is 100. Just for you to know, a list can hold a couple of dictionaries as well. As you can see here, let's try to print it. Print total grades. And as you can see, here is our output. In order to access our first dictionary, we can use the index of 0. It will give us the first dictionary. And then we can access a specific item from this dictionary. For example, history. We can use a for loop in order to iterate over our list and dictionaries. Let's say that I am looking to get each website independently. I can do for website in websites, and then I will print each website. Let's run it. Okay, and now let's iterate over our grades dictionary. For grade in grades, print grade. Here it will only give us the keys. So we should do this. We should specify our dictionary and then use grade as an index. Okay, and let's try to print it now. And now we got our values. Here we have a list which contains a bunch of dictionaries. Let's try to extract each URL and status code from this. We can do for status in websites status. And let's try to print status just to see what we get from the output. And as you can see, we got each dictionary. So we know that status is just a dictionary. So let's try to extract the URL value. And also, I will be happy to extract the status code value. So I can do status and use the status code key. Let's try to print it now again. And as you can see, we got our values. We can use a while loop in order to do a certain operation based off a specified condition. We can write while true. And here, no matter what, our code will keep running. We can do print code is running always because of the while true loop. Let's try to execute it. And as you can see, it is always running. We can also execute while loops based off a specified condition. Let's declare a variable which is going to have a Boolean value of true. And here we can do while status is equivalent to true, run this. And then let's import the time library. Import time. We will do time sleep for 5 seconds. And after 5 seconds, we will change our status variable from true to false, and it will stop our loop. So we can do status and change it to false. And then we should print loop has stopped. Let's try to run it now. After 5 seconds, our loop has stopped. We can use if statements in order to declare an action based off a specified value. For example, let's write our if statement. We can do this. If score is more than 80, print you have passed the test. Let's try to run it now. And as you can see, we got our results. Then we can specify an else block. And then we can print you have not passed the test. Let's try to change it from 80 to 60. And as you can see, this is what we got. We can use else if in order to specify another specific condition. We can do else if score is more than 70. Then print you have almost passed the test. Let's try to run it now, and we will change the score to 72. And as you can see, that's the result we got. In programming, we should use try and except. It means that if there is an error, our function will not terminate. So let's do except exception as error, and then we will print the error in case there is any. Imagine that we use a while loop in order to run our function. Without using try and except, whenever there is an error, our program will terminate it. So when we use try and except, our program is much more safer, because that once there is an error, our program will keep running and will not be terminated. Let's say that you have a large-scale software with a lot of users and so on. You don't want that your software will stop working in case there is any error. That's why we are using try and except. In other programming, it is called try and catch. So it allows us to catch errors in a safe way. If we want to combine string with variables, we can do this. We can use the f keyword and print our string, for example, my name is, and then we should use brackets and specify our variables. Or we can use another option, which is this. I will remove the f string here, and I will remove this as well. I will leave a space here, and I will write plus, and then specify my variable. Both cases give us the same result. In order to keep our code much more organized, we should use functions. We can declare a function by using the def keyword and then specify the name of our function. We will call it HTTP. Under that, we can start declaring our code. Let's have a simple print statement. And we are going to write hello from my function. If we try to execute it now, nothing will happen. We should call our function. So let's write its name, HTTP. And now let's try to print it. And as you can see, we got our output. Functions can call other functions as well. Let's declare a second function. We will call it second function, for example. And here under that, I will write hello from second function. Hello from our second function. Let's try to call it on our first function. And let's take a look at the output now. And as you can see, first we call our function, our initial function, which is the HTTP one, and then we call our second one. Functions can also accept parameters. Let's take name as a parameter. And then I should print hello and specify the name as well. Let's here, of course, store a name. I will call it Omri. And as you can see, we got hello Omri. We should add an empty space here. It will make it look better. And as you can see, this is the output. If you have a variable outside your function and you want to access him within the scope of your function, then you should use a global variable. First of all, I am going to declare a function. We can call it HTTP. And now the first thing I am going to do is to declare a variable which is called number. This variable is going to be outside the scope of our function. It is going to be outside of our function. And then from within the scope of our function, I will try to increment its value. Okay, wait, first of all, I will call the function. And now I will increment the value of number by 1. Let's try to run it. And as you can see, we got an error. It tells us that we cannot access the variable called number. So I should use the global keyword in order to change the access to number so that now we can access him within our function. So by using the global keyword, it means that we declared it as a global variable, and now we are being allowed to access it and modify it from within our function. Let's try to run it now. And as you can see, we didn't get an error now. I will try to print the number. And as you can see, we got 1. We can use a for loop in order to call our function more than once. So let's do it. And now I will nest our function inside of this scope. And let's see the results. So as you can see, our global variable, which is a number, was being incremented correctly. We already know that in order to add data into our function, all what we need to do is just to pass parameters. So if I am looking to pass a third item, I can just specify it here and say item 3. I can call it whatever I want, of course, and let's just print it. And here we go, we managed to add a new entity into our function without a problem. But there is a problem actually. Sometimes, at certain points, we don't really know the exact amount of items we are looking to pass into our function. As you can see here, whenever I am looking to add a new entity, I will be compelled to add it here as a new parameter. But what if I don't know the exact amount of entities I am looking to append into my function? For this use case, using args should be a very good decision. Let's remove everything and specify args. You can call it whatever you want, but it's a good convention to call it args. And then we should specify this and take a look at the output now. As you can see, we managed to insert a couple of items all into one parameter. Whenever we want to change it, we can easily add new items, and we are not compelled to add new parameters. All of those are packed into this parameter. You might ask yourself, what is this symbol? So in other programming languages, such as C, it represents pointers, but it is not the case here. Thankfully, in Python, we don't have to deal with pointers. So let me show you, let me comment this. And I will print this simple list, and I will specify this symbol. Let's take a look at the output. As you can see, it unpacked the whole list. And this is what it does. Whenever you call it on lists or variables and so on, it will unpack. This operator is called the unpacking operator. But whenever you call it inside of function parameters, it will do the opposite. It will pack the data. As you can see here, the data is packed. And let's run this again. Here the data is unpacked. So that's the whole difference. Now we should learn about kwargs. It does the exact same things, but it works with a different set of data. When we use kwargs, we are working with key value pairs, and we should specify double asterisks. So let's take a look at the output, and as you can see, it does the exact same thing. Concurrency and parallelism are techniques which are heavily used nowadays. Whether it's inside of backend development or finance, knowing how to take advantage of those techniques can lead you to a better programmer and will allow you to write much more efficient and better software. This video aims to teach you all what you need in order to start using those techniques. Let's make a program which is not going to use concurrent execution or parallel execution. First, our program is going to be quite simple. We will iterate over those URLs and send a GET request to each one. Then we can measure the time and see the differences between how much time it took for us before using threads and multiprocessing and after using those methods. Let's start making our function. We will call it HTTP and we will accept a DNS as a parameter. And now we should use try and except. It is always recommended. Except exception SE as error, and then we will print the error in case there is any. And now we will start making our GET request. I will specify the DNS and I am going to print the response status code. And before that, also the response URL. Response URL. And to me, it seems like we are quite ready. Now I will iterate over those URLs and then I will call our function per each URL. So for URL in URLs, and let's call our function and send a URL as a parameter. Before that, I will do start time and we will call the time method on the time object. And later I will do this end time, and then I will also call it again. And I will make a variable which is called total time. And now we can do end time minus start time. And this variable will give us the total time the whole operation took from the start to finish. So now I can print it. Total time it took without threading or multiprocessing is, and we can output our variable. Those are the URLs, and let's execute our code. As you can see, take a look at the output. Each URL is waiting to be completed before moving to the second URL. And the total time it took for us is 11 seconds. Now we can use threading in order to see the differences. Let's make a thread variable. I will increase the screen a bit first of all. Okay. Now we should use the thread keyword, which we got from our library, from the threading library. And here we should use target in order to specify our function. We should use target. It allows us to choose what function we want to run, which in our case is the HTTP function. And then we should use args. It stands for arguments. So we should specify the DNS we are looking to send. Okay. And now doing this line alone by itself is not enough. We should start each thread. So we should call thread.start. And here we should make an empty list which will hold all the threads. And let's append each thread to this list. So threads, and we should call the append method and append each thread. Let's iterate over our threads array. So I should do for thread in threads. And now I should call the join method on each thread. It makes sure that each thread is finished before that we are moving to the rest of our code, which is here. Now I will change our print statement to this. So total time it took. Now we are using threading. So I will remove it. I will modify it a bit. So total time it took with threading is. And now let's see the results. Before that, it took for us 11 seconds. So let's comment it. The time it took before using threads is 11 seconds. And now let's see the time it takes with threads. So take a look. Before it took us 11 seconds and now it doesn't even take us 2 seconds. So as you can see, the differences are insane. You might ask yourself what just happened. I mean, how did we manage to reduce the time from 11 seconds to not even 2 seconds? Well, here comes the magic of threading. When we use concurrent execution or so-called threading, it means that we can run our program in a much more efficient way. When we don't use threading, we are sending a GET request for each URL and then we are waiting for it to get a response and so on and so on. And that's the exact process for each URL you are currently seeing here. But the case is, with threading, we don't have to wait the entire time it takes for each URL to get a response. We are not compelled to do it. By the time it takes for Google to give us a response, we can move and send a GET request to the second URL. And that's what is happening here. Because that it takes so quick to run our code, there can be a false impression of claiming that each URL is running independently and is getting its request at the same time, but this is a twisted perspective and it is not necessarily true, because that there is a thing which is called the GIL in Python, and when we use threading, we are not sending a GET request to each URL at the same time, but as I said before, by the time it takes for one URL to get a response, we can move to the other one. If we do want to send a GET request to each URL at the same time, we can use multiprocessing. So it will spawn each process, and each process is going to have its own memory space and resources, and each process is not going to be dependent on the other one. So when we use multiprocessing, each process is running independently, and you can claim that all URLs are getting their requests at the same time. So now let's run it with multiprocessing. Okay. Now I will nest the whole code under it. This line is required for using multiprocessing. Make sure to put everything under it. And now we can start running our code. And as you can see, currently we are using multiprocessing, and that's our time. Always make sure to use this line when using multiprocessing. It prevents bugs, and I'm quite sure that you cannot even use multiprocessing without this line, so you should use it by default, which is good. So let's try to run it, and as you can see, it requires us to use this. In our case, our threads do not share any state between each other, but there are some special cases where we need to share a state between each thread. And then, in order to do it in a safe way, we should use what is called mutexes. So I am going to show it now. Let's make a variable which is going to get called number. The initial value is going to be 0, and then I will make a list which is going to store our results. I will declare it as an empty list, and now let's make each thread append its result into this list, and also increment this number variable which is going to represent each iteration. So first of all, let's increment the number. So I can do number and increment it by 1. And then let's append our results into our list. Results, and let's append our object. And the values we are looking to send into our list are those. The first one is going to be an index, which is going to represent each iteration. the value is going to be a number, and then the second value is going to be the URL. So let's specify the response.url. Okay. And the third one is going to be the status code. Why not? Status. And here I will call the status code method over our response. So response.statuscode. And now it is quite okay, but it's not enough yet. We should use mutexes and we should import the lock keyword. We should define it here. It makes sure that each thread can access our data at a time. So only one single thread can access our data at a single time. And then it prevents a collision where all threads are trying to access our data at the same time. It can lead to a lot of problems, and that's why it is recommended to use mutexes in order to prevent any future issues. Okay, but it is not enough. We should use the variable here and then nest our code inside of it. And it makes sure that our code is safe. We should nest it as well, sorry. And now it is quite good. And let's iterate over our results to take a look at our list. So for result in results, and I will print each result. Let's take a look at it now. And as you can see, we can see our results. Take a look at our API. Imagine that we have a function which is doing background tasks. So let's try to simulate it. I can declare it here, def background tasks. It will take a title, for example, and let's simulate that it is doing a certain work. While true, it will increment a number by 1. So I will declare a number here. While true, number is going to get incremented by 1 each time. And I will use try and except. Okay, I will go here, except exception SE. And I will print the error in case there is any. First of all, we should call our function, of course. I will call our function and I will specify our title as a parameter. We can just print the title, why not? And I am going to call it now. So as you can see, let's try to access any of the routes. The GET request route is working as expected, but the moment I am going to create a new entity via a POST request, take a look at what happens. We cannot even access any of our routes. And it is because that this function is running on the background. I will even print the number so that you can see it. Let's run it again. And this chunk of code is blocking the whole API. So we cannot have this background task running and at the same time serve our API. So it causes a bottleneck, a problem. So in order to solve it, we can use threading. So let's convert it from a normal function to a threaded function. We should call the thread keyword, and that's the exact same method as before. We should specify a target, which in our case is the background tasks function. Oh, my bad. I will just copy this one. And now we should specify arguments, which are the parameters as well. Okay, I can comment this. And all what we have to do here, since it's only a single thread, is to do thread and call the start method on it. And it is all what it takes. We are ready now. We can execute our background task. And at the same time, we can also access other routes as well. As you can see, our background task is currently running. In order to install Postman, we should open our browser and type Postman. Postman is an excellent software which allows us to interact with our API, and it is widely used within backend development. Okay, and now we should press on download Postman, and let's press on this. Let's wait for it to download. Here it is. We can press on it. Here it is. Everything is working, and I truly recommend you to do continue with Google so that you will be capable of using all the features in Postman. And also you can work with Postman from everywhere. Here we have a sample API. Let's copy it into Postman and send our GET request. So as you can see, we can interact with our API with Postman, and let's create a new collection. I will rename it to to-do list. And then we can save our routes inside of this collection. So I can save it under the to-do list. And I can name it, so I will call it list of to-dos. So then everything stays organized, and because that I am logged in into Postman, I can then install it in another computer and then still use all of the routes. Imagine that we have a very large computer which contains a lot of softwares. In order to interact with a specific software, we should specify its port. So we should specify the IP address of the computer, of course, but then we should specify the actual port of the service we are looking to interact with. So a port is quite like an identifier for each service. Here, as you can see, we are using port 4000 in order to host our website. This is just a small web application, nothing too fancy. And the moment I will go here, once I will go to port 4000, I will be able to access my website. Here is the port, but port 4000 isn't common for websites. Most of the time, websites will use port 443 or 80 as their port, and port 443 is much more common because it enables secured communication. Okay, so we can tell that each website has its own IP address, but whenever we access a website, we don't have to type its IP address. And it is because of a thing which is called a DNS. DNS allows us to map a specific name to a certain IP, so that then in order to access the services under this IP, we can specify its DNS. So take a look at this URL. In order to access this website, I don't specify its IP, even though it has an IP, of course. I specify its DNS. If we had to memorize an IP address for each website, it could have been much harder. So take a look at this image. As you can see, this image shows us what an API is. So we have the client. The client is the actual UI and the actual website itself. And then we have the backend, which is our server, or so-called an API. The API accepts a couple of methods, such as getRequest, postRequest, put, and delete. We will go over each one of them. But the main key point is that the actual thing, the actual responsibility of an API is to go to the database, pull data from the database, and send it into our client. So let's say that you are in a website which has a lot of data and you requested a certain entity. Then you communicate with the web server, which is in our case the API. The API goes into the database and gets the certain entity you have requested, and then it sends it into the client. So as you can see here, we send the request, and then we go into the API. The API itself communicates with the database and then sends the response from the database into the client. So as you can see here, we have our first method, which it is just a GET request. And as you can see, we communicate with the database, we do select all from to-dos, and then we send the response into the client. So if our client would love to go and get all the to-dos we have in our database, he will request this API. But first of all, we should create a table, so we can create the to-dos table. So we can do create table to-dos, and let's open the brackets. And the first column is going to be ID serial primary key, and the second one is going to be title, and the last one is going to be description, and it is going to have a type text as well. Now we can go into the beaver and then execute this. Let's do select all from to-dos. Okay, and as you can see, our table has been successfully created. And now let's try to insert our first to-do into this table. So insert into to-dos, and then we can specify the columns and also the values we are going to send. So now we will specify the values. The first to-do's title is going to be my first to-do, and the other value, my first to-do description. Okay, now I will execute this, and now I will select all from our table again to see if the data has been inserted successfully. Even though that it says that everything is good here, I'll have to take a look. Okay, so now we can move on. So before, I've been telling you that the API communicates with the database and then sends the actual data, so I will emphasize it. This is Postman. It allows us to interact with the backend. As you can see, I am using it quite a lot. Those are all the routes. And in order to communicate with our API, we should specify its route. So we are running on localhost port 8000, so we can specify it. Let's take this route and just modify the actual URL of this. 1 second. Okay, let's put the appropriate port, and now we can put the rest of our route, which is this. But before sending the request, we should turn on our API. So let's do Python API to turn it on. And now let's execute our first request, which is a GET request, which allows us to get our to-dos. So as you can see, I specified here that the request is going to be GET, and this is our route. So in our request, we specify the HTTP method and the relevant route. And as you can see, here is our data, which is exactly what we were requesting here. Select all from to-dos. Okay, before I continue, I would love to go over the code and explain about what is going on here. So first, we should start with the database file. As you can see, I call this function, the get database connection from our database file. This file and this function specifically is responsible for initializing a connection into our Postgres database, and it uses those credentials from our constants.py file, which just has static variables, which allow us to connect into our Postgres database. So as you can see, I am importing it here, and then I call it here in order to communicate with Postgres. And then the cursor object has a couple of methods such as execute, which allows me to execute SQL commands. And then I send the actual response from the database and its status code. As you can see right now, I am inside of the Postgres shell. And if I go here and see our database name, it says that we are working inside of the systems database. So we can do L in order to display all the databases. And then we can go into this database. I will clean the terminal, and then we can do display tables /dt in order to display all the tables, and we can do select all from users in order to see, not from users, this is not the correct table, I'm sorry, select all from to-dos in order to see our data here directly in the database. So when we are using an API, all what we do is communicating with the database. So we can go back here. As you can see, the moment I send the GET request, the API communicates with the database itself and then pulls all the data. And as you can see, this data is exactly the same as here, but we are just using the command in order to get the to-dos in our API instead of using it directly inside the database. So as you can see, I can do select all from Todos, and this is the exact same command I am using inside of my API. Okay, so let's explain about this part. As you can see, we have try and except in our function. Try and except makes sure that whenever we have an error, an unknown error, our program will not terminate. This is a must thing when working in backend development, because that if we wouldn't use try and except, our program would have been terminated every time there is an error. We call finally in order to close the database connection. Once we send a response to the client, we don't have to keep the database connection open. Therefore, it means that we can just close it in order not to waste any resources in the server itself, because that if the database connection will always be open without a reason, it is just going to waste a lot of CPU and memory usage, and we don't want it. Okay, and then we have this section. Here, basically all what we do is debug true. It means that if we change the code, our API will refresh immediately without me having to turn it on again. For example, turning it on again means that I will have to terminate the program and do Python API.py again in order to turn it on. But here, since we have debug true, I don't always have to do it. The changes will reflect immediately. And then we have our host, which is localhost. It means that our API is going to be running on localhost, and then we specify our port, which is port 8000, as you can see here. Okay, after all of that, now we can continue with our API. Now we are going to make our second route. So what we can do is to copy this chunk of code, because there is a lot of repetitive code, so we don't have to write it again from scratch. And now I will change it to get a specific to-do. So now I am not going to get all the to-dos, I am going to get a specific to-do. First of all, I will add a couple of more to-dos, so I can do insert into to-dos, and I will insert data again, title, description, and then specify the values. Second to-do, and second description, we can call it. Now let's execute it, and insert our third to-do. And as you can see, once we do select all from to-dos, we will have two additional to-dos. So I can do select all from to-dos again. And as you can see, here are all of our entities. Okay, so we specified in our route that we are looking to get a to-do, and we should also pass it to our function. And then we can print it, for example. So let's do print ID. And now I will just send a GET request again. As you can see, now we managed to print the dynamic parameter we sent via our route. So this is our ID, which is 1. And now I can modify my query to use this ID. So I can do select all from to-dos, where ID is equivalent to our specified ID. So I can do this. Sorry, this is not the right keyword. I can do this and then specify our ID here. And now let's take a look at our route again. Once we did our GET request again, we selected a specific to-do which is related to the ID we specified. So now if I'm looking to get, let's go here again, our second to-do, I can specify its ID and just do send. Back then we were talking about different HTTP methods. So as you can see, here we have the 4 basic methods, and here we are focusing currently on the get method, which allows us to retrieve data, to get data. Now, let's say that I am looking to delete a specific to-do. I can copy this function again, but we should make sure that our functions have distinct names. So now I am going to do delete to do. So I will call it delete to do. If we have functions with the same name, we will get an error. So each function name should be unique. Okay, so I will change it to get Todos. And here I can do get specific to do. And I think that we are quite ready to move on. Okay, so we can now start working on our delete request. I can do delete from Todos, where ID, and then specify our dynamic parameter. Here we specify that we are looking to use a parameter. So this is our symbol which represents our parameter, since that we cannot inject directly parameters here because this is a risk of SQL injection. So if I would specify ID directly here, for example, I can do it like this. Take a look. I can do it like this and then specify the ID, but this thing means that our API is not secured and that we can have an SQL injection risk. So if someone, for example, instead of a parameter is going to do drop table users, for example, and we have table called users inside of our database, it will work. And this is why you can never use raw SQL inside of your query. You should use this symbol, which makes sure to filter out any malicious code from our SQL statements. And here you can specify the ID or the variable you are looking to use. Okay. By doing this method, you are completely safe from any SQL injections and you shouldn't worry about it. This is the standard way, by the way, and let me overview this again. Delete from Todos, where ID, and here we specify our ID. And sometimes, in those cases, we should do Postgres commit. In other libraries, you don't have to do it, but for certain operations, such as removing, posting, and maybe updating, sometimes we should commit the changes. And then we can do this here, because there is nothing to fetch, we just deleted an entity. So we can do entity deleted and specify the status code. Maybe we can do to do deleted. And now let's try to specify a delete route and delete the first to do. Make sure that you specify a delete HTTP method. We should turn our API on again. API.py. Method not allowed. Why is that? Let's see. Okay, and here another mistake. As you can see, I forgot to change the method from get to delete. So let's do it. And now it should work. Make sure to specify the appropriate method here as well. And as you can see, we got our response. And now let's go into the database to see if everything has been working correctly. And as you can see, we managed to delete our first to-do. A quick tip in Postman, you can do what is called a collection. For example, you can do here a new collection, and then you can call it whatever you want. You can press here and do rename and do to-do collection, or just call it to-do API, and then you can save your routes. So in case that you are going to use them again in the future, you can save them here under your specified collection, and then you can call it whatever you want. So get to do. This function gives us all the to-dos, so I will change it to get to-dos, and then also the other function, delete specified to-do, which is going to be under our to-do API collection. Okay, and now we can move on. Okay, so now I will show you how we can create new to-dos. So we can copy this and make sure to give this function a distinct name. So we can do post to do. And you know what? We can change the route. You don't must to do it since that this route has a different HTTP method, but you can still do it if you want. Okay, so a method is going to be of a kind post. So this is our method right now. You should write it as a camel case post. And now I will show you how to retrieve data. I will just send a sample response and just show you how we can retrieve data from our API, from our request. First of all, I will specify the relevant route, which is this route. Hold on. Okay, so this is our route. And now we would love to specify just the title and the description for our to-do. So our title is going to be a post to do, for example, and then our description is going to be post to do description, for example. And now I will show you how we can get the data. I will comment this thing out and also this one, and then just show you how we can gather all the data together. So I can do data and then do request and call the JSON method on it, and then I will just print the data. Before that, we should make sure that our function isn't taking any unused parameters, such as ID. We don't use it anymore. In our route here, we don't even specify it, so we can remove it. So it won't be a parameter inside of our function. And now I will make sure to remove the brackets from the JSON here. We should just call it like this. And let's try to send a request. We got test. And as you can see, this is our data. So it is a dictionary. And then let's say that in order to get a specific entity, which is related to our data, we can do just a basic dictionary method. So I can do data get and then specify the keys. So I am looking to get the value for title, and here now I am looking to get the value for description. So I can do data get and then specify description. Now instead of printing the total amount of data, we can just print the necessary values we are looking to retrieve. Once we did this, now let's execute our request again. And as you can see, here is all of our values. And now we should insert them into the database. So let's do this. Cursor.execute. We should call the execute method. And then insert into to-dos, specify the columns, exactly as how we did here before with our insert statement. So we are looking to insert data into title and description, and then just specify our values. If we have two values, we should specify it twice. And then, of course, specify the variables we are looking to send, which are title and description. After that, we should do Postgres commit in order to insert the data. And then we can do here returning all in order to get all the data we have been inserting. So I will delete this line, and here I will specify the response. To me, it seems like we are all set and we can move on. And as you can see, here is our created to-do. Okay, now what if we want to update a certain entity, to modify a certain to-do? Now we can do a patch request, which will allow it to be happening. Let's do select all from to-dos again. And let's say that I am looking to change to-do number 3. So I am looking to update its title. I can do update to-do. We specify the table's name, and then we can do set title. for example, modified to do, where ID is equivalent to ID number 3, which is the ID of our third to do. And now let's select it again. As you can see, here is the new modified to do. So we can just do it in our API. So I will change it from post to patch. Patch allows us to change a certain entity inside of our database. And then I can just use the query. Okay, so I can do this, update to-dos. Let's say that we are looking to update the title. I can do that. I will remove the description since it doesn't matter now. Set title equivalent to this, which this is our dynamic parameter, where ID is equivalent to this as well. And here we should specify two variables. The first one is the title, and the second one is the specified entity ID. Okay, so now here we should accept an ID as well, and we should accept it inside of our function. And we can call it patch to do. Here we can also do returning all, which will return the new changes. So we can do returning all. And we can test it now. So as you can see, we specified our ID, which is the ID we are looking to update. In our case, this ID is ID number 3. And then we specified our new data, our new title. So now let's do select all from to-dos. The to-do is modified to-do. And let's try to change it to patch request test. As you can see, the request is working. We got our new updated data. Let's try to select all from to-dos again. And as you can see, we managed to successfully change entity number 3. Okay, another thing I would love to show you is that sometimes in the backend we have external processing. What does it mean? Imagine that you would want to do any processing in the backend after that each to-do has been sent. So now, in order to do this, we should call a function inside of our post request. So where is it? We can go to our post request. Just in theory, imagine that there are every calculations or any things you want to be running inside the backend in the background. So now, if we would call a function, we can maybe first declare a function. So I will first declare a function. I can call it every work. Imagine that this thing is some every work which is running inside of the backend. And then you can just, for example, I am just doing a simulation here, while true. And then I will increase the number by 1. And then I will print the number. So all I am doing here is just simulating a heavy work which might be running on the backend. On a real world use case, the function is going to be another function, of course, but this is just for simulation. And now let's say that we are looking to call this function. This function can even accept a parameter, just for an example. Specified title is, and then we can specify our title. Let's put a gap here. And we can wrap it with try and accept. Accept, exception SE, and print E. Okay, so this is our exception. It will print our error. And now let's try to call this function. So this function is going to run after we send a new to-do, after we post a new to-do. So we can call every work and just insert the title. Okay, and now let's see what is going to happen after this. So I can do Python API.py again. Okay, I will save this route also. Post new to do. And now I will send the post request. So as you can see, we don't get a response. And why is that? It is because that our function is being used, and it doesn't leave any space for our API to send a response. And this is not good, because this function is going to always analyze and run, as you can see here. But we don't want that our response is going to take forever. We should get a response after we send the data. It happens because that here our function takes the data and doesn't leave any time for our post-to-do route to send a response. In order to prevent this type of thing and make sure that our every work function stays in the background and doesn't interrupt our API cycle, we should use what is called threading. And I have a video about it as well in my channel. If you want, you can take a look. So then we can send a response and still use our function in the background without doing any bad things into the API itself, without interrupting the API. In order to solve this issue, we should wrap our function inside of a thread and call it in a different way. First of all, I should import the threading library. So I can do it from threading import thread, and then nest our function inside of a thread. So let's go to our route. Instead of calling this function like this normally, we should have a variable called thread and use the thread keyword with a camel case, and then inside of a target specify our function, which is every work, and then add another thing which is called args, which stands for arguments. So here we are going to specify our parameters. I will put it like this as well, inside of brackets. And to me it seems like we are all ready. And we can start this thread. And those two lines will make sure that our process is going to be running in the background without interrupting our main application. If you want, you can read more about it, about the GIL, about multiprocessing and threading. Okay, so let's try to send a post request again and see what is going to happen. As you can see, we got our response immediately, and our function is running on the background. Okay, so now we can also access other routes as well. When we call it normally without threads, our function will block all the other routes and our API will not be servable, and we will not be able to use our API. For example, on the newest version of Flask, each route is running inside of an isolated thread. But let's see what would happen if the case was different. So I can do threaded and then I can do false, just to emphasize. And now I will run it again. Oh, sorry. Threaded. And now let's try to hit a post request. First I will do get request. And as you can see, our API is working. And now when we post a new entity, our function is going to run and block our API. So as you can see, we cannot access all the routes. No matter what routes we specify, we can't access because that this function, this chunk of code is blocking the access to the rest of the API. The fact that your web application is working on your machine doesn't necessarily mean that it will work on the server. In the end, after that you've finished working on your project, you are looking to deploy it somewhere. Your web application requires to have Python installed and all kind of libraries, in order to function properly, but no one can guarantee that the server will have all those dependencies. We can use Docker in order to store our web application inside of a container, and this container will contain all what the application needs in order to run. So as you can see here, we have our code, we have a to-do list API, and I am going to Dockerize it via Docker, and then by the fact that our code is going to be inside of a container, it will allow us to run it everywhere without worrying about dependencies and more. This project is quite the same as before, but this time we are using environment variables in order to declare our connection details. Here, as you can see, we have host docker internal. It allows us to communicate with the host IP. I am the host, which is hosting the Docker containers. It allows them to connect to my IP in order to initialize a connection to Postgres. And here we have the rest of the credentials. Docker container has its own kind of network, and that's why I cannot specify localhost. If I will specify localhost, it will refer to localhost inside of the container and not to my localhost. That's why we should write host docker internal. Okay, let's take a look at the other files. Here we have the requirements text file. Here we specify all the libraries our container should use in order to function properly. And let's move to the Docker file. Here we have our table, of course. Okay, and this thing is a based image. You can imagine it as a small Linux server where we will host our application. This image gives us a good server, which is truly optimized for Python. It is a small Linux server, you can imagine it as is, and this line represents our working directory within the server. All of our files will start in the app directory, which is this. Then we have this file, which will copy our requirements.txt file under this directory, and it will create a same file with the same name. And then we will download all the dependencies from this file. And then we have the copy here. It will copy all the files on the left to our destination folder, which is our work directory. Here we are writing expose 5000 only for documentation purposes. And after that, we will run our web application. In this function, we are using our environment variables, of course. And now let's try to run it. We can do docker build and we will give it a name. Let's give our image a specific name. We will call it backend and I will specify the dot. This makes Docker look for a Docker file and we can run it. Let's wait for it to build the image. It was quite quick. We can do Docker images in order to display all the images. I will increase the screen a bit. Okay, and now let's try to run it. Docker run. Let's map ports. We map the inner port from our container to our port, which is 5000, so then we can access it. And let's specify the name of the image. We can specify the image ID and let's press enter. Okay, and now I will try to access any of our API endpoints. And as you can see, here we have our data. And it means that we were able to launch our web application inside of a Docker container, which contains all the dependencies it needs to run. It means that now I can deploy it anywhere in the world and it will work as expected, without me having to worry about setting up the dependencies on the server and more. Sometimes we might want to store our Docker files in a repository, which we can access from other computers as well. That's why it might be a good idea to use Docker Hub in order to store our Docker images. And now I am going to show you how to do it. I would love to start from zero, so that's why I have a new project here. And as you can see, it is just a simple API endpoint which returns hello world. And now let's go over the Docker file. As you can see here, we have our Docker file. And here we list all the dependencies. The only dependency which we have is Flask. And let's start Dockerizing our project. I can do docker build and give it a tag name. I will call it hello world endpoint, quite a long name. And let's wait for it to finish. Okay, it was quite quick. Now let's list all the Docker images. And let's try to run our Docker image just for testing so that we can see if everything is working correctly. I can do docker run and map ports, of course. And let's specify the Docker image ID. And as you can see, here we have our endpoint as well. And now let's create a repository which will contain our Docker image so that then we can access it from any computer we want. I will call it Python hello world. Our repository will store our Docker image, and then we can pull the image from anywhere we want. But the first step is to upload our image into this repository. So let's do it. We can go to VS Code and let's display our image. We can do Docker images and we should give it a tag. So I can do Docker tag and specify our repository. I will give it an initial tag of v1 since this is the first upload we are doing. Whenever we upgrade our image, we should also upgrade the tag name. So in the next upload, I will call it v2. It is good because that it allows us to keep control over all the upgrades. Okay, and now we should do Docker images. And we should write this Docker push and specify this. Of course, it's not enough. We should include our tag, which is v1. And now let's try to execute this command. We can wait for it to load. Okay, let's take a look at Docker Hub. And as you can see, here we have our new image. So it seems like everything is working correctly. And now I will show you how to pull this image. Let's say that now I am from another computer and I want to use this image. So let's do it. I will pull it now from this repository. First of all, I will clean all the old images. So I can do Docker images and I will clean them. Let's delete all of them. Okay, I will clean the terminal as well. And now in order to pull this Docker image, we should specify this command, docker pull, and specify the image name and the tag name. We can press on this and copy this value. And now it will pull it directly to our computer. Let's display it. And let's try to run it now. Docker run. I will specify the image ID. And of course, I should map the ports. And here we have the same output as before. And whenever you want to pull a certain image, please mention all the value. You should mention the repository name along with the image name and its tag. So you should mention everything. You can save your Docker image inside of a USB, for example, so then you can later go and transfer it to another PC. In order to do it, we should first take a look at our images, and then we can do the following command, docker save, and we should specify this flag, which stands for output. We can call it whatever we want, but we should end it with an extension which is .tar. And then we should specify our image name along with its tag. Let's wait for it. Okay, seems quite good. I will remove the old image so that I can show you how to load it from our backend.tar file, docker rmi, and let's specify the image ID in order to remove it. Okay, let's verify it, and now we don't have any images left. And in order to load it, in order to actually use this Docker image, we can do docker load and specify the I flag, which stands for image, and specify the file name, which is backend.tar. Let's wait for it to load as well. And we can do docker images. And as you can see, here we have our image. Let's take a look at Docker Compose. It allows us to build and run a couple of Docker images at once. So take a look at this section. Here we tell Docker to go to our app directory, and as long as there is a Docker file, Docker will build this Docker file and will run it. And here we specify the environment variables. So take a look, here we have the Docker file, and this is our code, and we accept an environment variable here. Before that, as you can see, we have this thing which is called depends on. So it means that we will first build this image, which is the Postgres image, and currently we don't specify a directory. So Docker will pull this image from Docker Hub and will build it. And as you can see here, we wait for it because that we are using it here. So this is the connection string for Postgres. Here we specify the username, the password, and the endpoint of the database. So take a look at this. We called the Postgres service DB, so we are going to use it here. And this is the database name. So due to the depends on, before running this service, we are waiting for the Postgres service to run and be ready. Here we have what is called a bind mount. It means that any code changes we do here will be mapped to inside of the container. So whenever I change the code, it will refresh automatically. As you already know, Docker Compose is used to run the containers, not only to build them. So the moment I run this thing, it means that I will be able to edit my code as well, due to the fact that we map the code which I have here to our folder which is inside of the container. And here we specify the ports. We are looking to map port 5000 to port 5000 on our machine, so we can run it on port 5000. Let's take a look at the Postgres service. So here we pull the Postgres image from Docker Hub and we make a container out of it. Here we have the environment variables, and here we have what is called volumes. Docker will create a secret folder where it will save all the Postgres data from our container. So we will map this folder to the folder which is inside of the Postgres container, and whenever we have any changes in data, they will be saved in our folder as well. So this folder on the left is located on the host machine, and this folder is located under the container. And we will map this folder to this folder so that the changes will be reflected on this folder as well in order to save the data. Then we need to register the name of the volume, and we do it here in the volumes section. This is the Postgres port. On the right side we have the port of the container, and we map it to this port on our machine. Now all what is left for us is to run it. We can do docker compose app and wait for it to run. It seems like everything is working and we managed to access our API. So as you can see, we get a hello from Flask. And now let's go to this endpoint in order to see if we managed to establish a database connection. So I can do /db. And as you can see, we got database connected. So it means that we managed to connect to our Postgres container. Hi everyone, welcome to the course project. We will build a complete, fully functional REST API, and we will see how we can log in and register users in a secured way. We will see how to declare relationships between users and different entities. We will work a lot with Python and SQL. We will practice our queries and much more. In the end, we will also see how we can optimize our code for production environments so it runs safe and smoothly. Our project is going to be related to a book management system where users will be able to loan books. We will handle permissions. We will see how we can protect certain endpoints. For example, only allow admins to reach a certain endpoint. The best way to learn is by doing, and after finishing this project you will be able to write your own backends with Python and SQL. Thank you for watching and can't wait to see you start the project. Let's create authentication so users can sign up and also sign in. So the first thing we should do is create the tables, but first of all, let me show you the structure of the whole project, because the structure currently is a bit different. So take a look here, this is our main file, and here, in order not to put the whole code under the same file, we are using what is called blueprints. So this is our first blueprint, and once we go here, Flask will redirect us to this file, and here we can use the routes we are looking to use, of course. And the first route I will create now is the register route, which allows us to register users. Here is the file which is responsible for connecting to the database and allowing us to use the database. And here is the connection string. This is the Postgres protocol, the username, the password, and the address. And in the end, we have our database here, which is called guide. And take a look at this. As you can see now, we are using a pool, a connection pool. When using a pool, all what we do is that whenever we have a new request, we borrow a connection from the pool, and then once the request is finished, we release the connection back to the pool so other people can use it. Okay, so here we specify the URL for the database, so it allows us to connect to the database, and here, number one, it represents the minimum amount of connections, so we will always have at least one active connection, and here it represents the maximum amount of active connections. This technique is very good for production, and it is what is being used nowadays. Let's start creating our authentication. So the first thing I will do is create the table for the users. So I can do create table users, and the first column is going to be an ID, and the second one, username, is going to be of a type text, not null, and unique, of course. The third one is going to be password, which is also going to have the data type text, and it is going to be not null as well. And the third one is the user role. So I will make it not null as well, and I will specify a default value. The default value is going to be guest, and then I will make sure that there are only couple of roles which are available. So let's do it. Check, and I will declare it here, role in. So the only possible roles are admin and guest. Those are the available roles now, and it will be good for us for later for declaring permissions and much more. So for example, we can have specific routes which require admin. So then in order to do that, we should make sure that those roles are there. Currently, we want that in our web application, we will have only two possible roles, which are admin and guest. And that's what we do here. It will not be possible for us to insert a row which has a different value, which is not admin or guest. I forgot to add here the data type, which is text, so make sure to add it. And now let's copy and paste it into Postgres. And the table has been created successfully. We can move on and start building our authentication. Here is the route which is responsible for registering users. In order to go to this route, we should go to api/v1/at and specify register. Now let's make sure to register users. So the first thing I will do is take the data from the request. So I can do request and specify the getJSON method. Make sure to change this from get to post. The only available method for this endpoint is post. So here we specify the available methods and we are ready. Okay, and as you can see down there, we can see the values. Let's extract them. I will declare a variable for each one. So let's do it. Username, and we can do data get username, and then let's make another one which is for password so that we can get the requested password. Now we should save the password and the username into the database, but we should make sure that we hash the password. We should never store a password in the database as is, because that we should assume that at some point a hacker will go and hack into our database, and that's why we should never store plain passwords. Let's hash our password. So I will make a variable which is called hashed password, and I will use bcrypt in order to hash the password, and then I will print it so you can see how it looks. Let's call the hash password method and specify our password, but first of all we should extract the password and the username from the data object. So I can do data and get and specify password, and I will do the same thing for the username. Data.get username. Okay, now we have the password and we should hash it. Let's specify the password and we should encode it. So let's do encode UTF-8, and here we should specify the hashing algorithm, which is bcrypt gensalt. We should call it here, and here we should call decode, and also again specify UTF-8 so that our hashed password will be in a good format. And before saving it into the database, let's just print it and let's send a request again. As you can see, here is our hashed password, and once the password has been hashed, no matter what we do, we cannot revert it. So that's how hashing works. It is different than encryption, because that once you encrypt something, if you have a certain key or a secret, you can revert and see the original value, but once you use hashing, you can't. We cannot turn this password, the hashed password, back to the original password. And now let's save the actual user into the database. So we should start writing our SQL code. So I can do cursor and call the execute method, and I can just do insert into users. I will specify the username and password columns, and I will specify the values. Okay, and let's use our variables. So the first variable is the username, and then here, as you can see, we store the hashed password. Make sure to store the hashed password and not the normal password. Okay, let's do returning username. We will return the username. And let's see, it seems like everything is correct. I will make sure to remove all the unnecessary things which are not needed. Okay, in the end, in order to commit the changes, we should call Postgres commit, and we are quite ready. Let's go and test our route. Okay, and we can go and take a look at the database. So let's do it. Let's open our database. We can do /L to see all the databases, and let's go to guide. Now we can do select all from users, and as you can see, here is our new user, but I would love to change the response. So I will do this response and cursor dot fetch one to fetch the newly created record. Now I will just print the response, and I would love to see how it goes. I will just insert another user. Okay, so here is our response. I will get the user name from the response, so it's the first element, and I will do this. I will use the f string, and I can do user and specify the username as being registered. Now it will give us a nice message to the client. Let's register again. And as you can see, user tester has been registered. Okay, so we already have step number 1. We managed to make it possible for users to register, and now we should make it possible for them to log in. So I will show you the whole process. We will take the exact same route, but we will change it from register to login. I will duplicate the tab in Postman. Make sure to work with Postman as well. It is a very good tool. And this is the user we just created. I will try to log in with the same user. Okay, so here we also take the username and the password, but now we will have to load the hashed password from the database, and then we will have to compare it with the password in the request. What we will do is this. We cannot compare this password with a complete hashed password, right? So we will also hash this password and then compare the two hashed passwords. If they are the same, the user will be able to log in. If they are not the same, he will not be able to log in. Let's remove this. Now we should also delete here. I will just say data just for now, and let's do this. We should do cursor.execute and do select all from users, where username is equivalent to this, and we should of course specify the username which comes from the request. And now we should fetch this, so let's do fetch one. Okay, I will put it under the response variable, and I will print the response. Also, make sure to have a distinct function name for each route. So I accidentally called it registered. I will change it to login. I cannot have two functions with the same name. It will throw an error. And let's run our code. Okay, and I will test this route. Let's go to Postman. Let's try to simulate a login. And as you can see, here we have our values, and here is our encrypted password. Now I will just extract all the fields from this, from the response. Let's take the user ID, for example. We will start with the first element, which is the user ID. So I can do user ID and take the first index, which is 0, of course. Then the next item is the user name. So I can do user and underscore name. And I will do response, and I will use index number 1. Then, of course, the password, user underscore password. And here we will use number 2 to extract the third element. As you already know, it starts from 0. So ID is 0, tester is 1, and our hashed password is located at number 2. Now, the final element, which is the role, I can do user underscore role and do response and get the last index. Okay, so here we have managed to extract all the values into variables. Now what I am going to do is this. We will make a comparison between the password which was specified in the request to the password which came from the database. Since the user password, the password from the database, is already hashed, we will have to hash password as well, and then compare the two hashed passwords. In order to do it, we can do this. We can do if and then call bcrypt and call the check password method on it, and it accepts two items. So let's insert our passwords there. We should first insert the password which came from the request. So let's do it. Password, and of course I will encode it with UTF-8, and then we will specify the second password, which is the password from the database, and I will encode it as well. So UTF-8 as well, and here I will print password match, and let's try to run it now. I will turn on the API again, and as you can see, we got passwords match. So if passwords match, we will return a token to the user, a JWT token, and in order to access the API, the user will need to specify the token. Otherwise, we can return this login as failed. Okay, and here let's simulate a token. Here I will put 401 unauthorized, and here we can do JSONify and simulate a token. Let's simulate a token and give a status code of 200. Protecting your web application with a token is a security standard nowadays. I can show you, for example, that I have made a web application and I also use it in this web application. So user must specify a token. This is a middleware. What you see here is quite irrelevant, but this is a middleware which requires a token to be sent with the request. So this is what we will do in our backend in Python. We will make sure that in order to access a certain route, people should specify a token. Otherwise, they will not be able to access the routes. Creating the token is quite simple. First of all, you should install pyjwt and then import all those libraries. And here we get all the values we created before, and then we create a payload out of them, and we store this payload under our token. So based off the payload, we create a token, and here we should specify a secret for the token. This is a secret you should never share with other people. And after that, the token will be created, and here are the values which are inside the token. The first one is user ID, the second username, the third one is role, and the other one, the fourth one, is expired. So in 1 day from now, the token will be expired. It is good due to security reasons, people do it. And after that, we can just test the route. And also, we will protect other routes based off this token. So in order for users to access routes, users will be able to specify this token. Otherwise, they will not be able to go to the routes. And users can get this token only after they have managed to log in. Let's clean our code and try to log in. Okay. And as you can see, here is our token. Okay, and now just for the example, let's create a protected route. I will create a new blueprint and I will call it test. This route is used just for testing, and I will create a new file, test.py. Let's copy the things I need from here. I don't need all of them, of course. I will call it test. And now, before running our program, we should import the test blueprint. So we can do from blueprints.test import test. And we should change it here. And now we are ready. Let's execute our code and test the new route. And as you can see, here is our new route. I have managed to access it, but I didn't specify a token. So I should protect it and now specify a sort of middleware which will check for JWT token before allowing us to reach this route. So let's do it. Take a look now. This is the function which requires us to store a JWT token with our request in order to access this protected route. So let's log in again. And as you can see, we got our new token. Now I will try to go to this route, and as you can see, it doesn't let me, but I will specify a token now. And as you can see, after specifying a token, I am capable of going into this route. And that's how you protect your API. This is the function which allows us to check for the token. I wanted to separate the logic, so I thought that it might be a better idea to put it here. As you can see, it is quite a lot of code, so I thought that it might be a better idea to put it in a separated place and just import it. So this is the approach we will have for all of our middlewares and checks. And what is going on here, all what is going on under the hood is that before we run the protected, we run this function and it checks if we have a token. If everything is okay and the token has been verified correctly, it will run the protected function. I know this function is indeed quite complicated and isn't that nice to look at, but this is what it does under the hood. It just calls it, check for a token, and then allows us to go and use the protected function if the token is correct. What you see here is called a decorator, and at a high level what is going on here is that whenever we go to the protected route, it will first of all run this function. It checks if the token is good and everything has been verified correctly, and if so, then in the final step it will run or return the protected function. So that's the whole process. When I click here, first this function is running, it checks for a token. If everything is good, in the end it will proceed to this protected function and will run it. Let's start creating the basic book routes. We will allow users to create, read, update, and delete books, and later we will move on to more advanced routes such as admin routes, which allow us to manage users and much more. We will take advantage of permissions and so on. So let's start. Let's go and create our new table. I will paste it here in Postgres. And now let's insert data into it. Okay, and it seems like we are ready. The only thing we should do now is create a new blueprint, which is used for our book routes. So I will call it books.py, and I will go to the main file and I will declare it there. So let's call it books. And for this moment, we can comment the test route since we don't really need him. I will just leave him commented here. And let's change it to books as well. And first, I will make the endpoint. And I will also make the blueprint. So let me do it. I will import all of those things. And I will call it books. And I will call it books as well here. And now I will import it. So from blueprints.books import books. I will take this and I will comment it as well. So we have our routes at the same order, and now we are ready to start building our book endpoints. Back then we were working with Postman, so now I want to go to Postman and make a new collection which is used for our API. I will call our API books, and here I will add folders, and under those folders I will add the appropriate requests. I can press on save and I will call this login, and I will store it under books under this folder. Okay, We can remove those, we don't really need them, to be honest. Now I will create a new folder, which is going to be the general folder for all of our book requests. So I will just call it books as well. And under that, I will put our endpoints and our requests. And now we are ready to start our request. So I will make the first endpoint. I can do books and I can specify the route. So I can do this and I can call it get. You can call it whatever you want. It doesn't really matter. And here I can do methods and I can only accept a get method. Now I will declare the function def get books, and here users will get all the books. Let's just return something simple, which is 200 and the string books, and I will go and test the endpoint. And as you can see, our endpoint is working, so I will save it as well. I will go back to save it under books, and I will do this, get active books. Or not active, available books. So this route will give us all the books which are available. Okay, and now we should import the pool and start using Postgres in order to get the books. So I will do it. Now we can start working on our queries. Make sure to import and use this. It makes sure that we return the data as a valid JSON. And let's start working on the query. I can do cursor execute, and I can do select all from books where available is equivalent to true. So I can do where available equals true. Now let's try to execute it. I can do response and cursor fetch all. Let's print the response, print response, and now I will go to this route. And it works. You can see all the books here. So let's just return the books. I will return them under the data key. And let's execute the request again. And as you can see, here we have all the books. And now we should use our token middleware on this. Currently, we don't specify a token. We should indeed specify a token in order to access this route. So let's do it. Let's call our middleware. Authenticate JWT token. That's the middleware we have used before, which is located here under the security file. And let's try to hit our request. As you can see, it doesn't let us. So let's log in again in order to get the token. Now let's specify the token. And as you can see, now we are capable of reading and seeing the books. Let's create a route which is used for posting books. Let's just call it post, but again, you can call it whatever you want. It doesn't really matter. And now the method we will use is post, and I will call it create books. This route in the end will be used only by admins. So if someone will try to access this route and it doesn't have a role which is related to admin, he will not be able to do it. We will read the user details based off the token he sends. Whenever someone sends a request, we can decode the token and then we can see all the details. Let's create the post books route so we can start executing the SQL. Insert into books. We should specify the columns, title, description, and the values, of course. Okay, but first of all, we should also extract the data from the request, so I will do it as well. Let's get the JSON data, so we can do data and request.getJSON method. And I will just extract the data, so I can do title data get title And the same for the description. Description data get description. Okay, let's uncomment the query and specify our variables. Now, since it's a post request, we should call Postgres commit. So let's do it. Postgres.commit. And it seems like we are quite ready. Let's do returning all. And here we can do cursor fetch 1. It will return us the new row we just inserted. Now I will test it in Postman. Let's test our endpoint. And of course, we should include the JWT token. And as you can see, here is our data, so we can return it. Let's try to hit the post request again. And here we go. This is our new inserted book. Now I will save it. Post new book. Admin only. In the end, this route is going to be available only for admins. Okay, let's save it. And here we go. We have our second route, which is for post request. Let's continue with our project. So currently we have a route which allows us to get books which are available and a route which allows us to post books. This route is going to be only for admins. We will do it later. Meanwhile, let's allow users to delete books and update books as well. Let's create a route which allows us to update the book title and the description as well. So I can copy this one and change it to update. Again, you can call it whatever you want. I just say update here so it makes a bit more sense, and I will change it to patch since it is the method which is being used for updating. And of course, I will accept an ID. So I will know what book to update, and I will take it here in the function as a parameter. And now all what is left is to change the SQL statement. Instead of inserting data, we will update data. So let's do it. I can do update books, set title, and specify this. And now description, and specify the same symbol as well, where ID equals. And now let me specify the parameters. So the first one is title, the second one is description, and the third one is the ID, of course. And here we can do returning all. Again, we should change the function name, of course, so I will call it update books. And now we are all set. We can go to Postman and test our route. Let me run our API. Okay, let's update book number 1. So I will specify its ID there, and let's start declaring the body of the request. The only fields I am looking to update are title and description. So I will just call it test. And now I will specify the description as well. And I will say test also. Let's try to hit this route. Oh, of course, we forgot to specify a token. And as you can see, our route is working correctly. Let's take a look at this route. Search for ID number 1. And as you can see, ID number 1 has been updated. Make sure to save this route into our collection. I will call it update book. And now let's move to the last route, which is used for delete requests. So I will copy it as well. And I will change it to delete. Here the method is going to be delete as well. And here I will change it to delete also. Delete book. Now I can leave all those things since we don't need them. We don't return anything once a book has been deleted. So I can just leave it like this, or just say book has been deleted. All what is left for us is just changing the SQL query. So let's do it. I can just specify the delete query, delete from books where ID, and specify the ID. It is a very simple query. And here I will specify the ID, which we got from our parameter. Now I can remove all those things since we don't really need them. We should call Postgres commit. And we are quite ready to test our route. And as you can see, we got book has been deleted. Let's search for ID number 1. So we can do select all from books where ID equals to 1. Let's run this. And as you can see, we get nothing. It means that our book has been deleted successfully. Here we have our function which checks for the token. And if the token has failed, it will not let us pass to our desired function, but this function also decodes the token. It means that it gives us the details about the user. So as you can see, it is being stored in the token payload. And if you remember, in the start, when we were creating the token, we stored all the details about the user, so it is under the token. So now we should decode the token in order to get those details. And now I am looking to pass this data to my route here so that I can use it and check the user role. So let's do it. In Flask, we have what is called a G. G is a global variable which is used between requests and it only lives by the time of the request. After that the request ends, it doesn't exist anymore, but we can declare it like this. We can do g.user and declare our token payload to be under that. And once we go to this route, we can access this data. So let me do this, print g.user. And now I will try to access this route and see the results. Let's go to Postman and create a new book. And let me print, and as you can see, this is the payload we got from the token. This is the whole details of the user. And now I can extract the role of the user from this. So here we go. I will just do print g.user.role, and I can do this. I can create a simple if statement on the top of our code, and I can do if, let me format it correctly, if g.user role is not equivalent to admin, then we can return an error. So I can do return JSONify, and you cannot access this route. So this is our message, 401. So it means that the user doesn't have the right permission. And now let's try to access this route again. First of all, let's take a look at the users. Select all from users. And we don't have an admin currently. So no matter what, we shouldn't be able to access this route. And let me try to eat this route in Postman. And as you can see here, we got failed. You cannot access this route. So we managed to make sure that this route only fits for admin. In the end, what you saw here was a core topic in backend development. It is important and necessary to know how to handle permissions, and the technique you've seen here is used everywhere. So in the end, it is quite straightforward. All what we do is declare a global variable which contains our user, and then we can access it whenever we want and apply our own custom logic. Controlling those things, knowing permissions well, SQL well, it will make your life easier when it comes to the backend, and I am talking from experience. I have managed very large backends with SQL, as you can see here, and here I document all the table changes and I write SQL by hand, and that's why I am showing it to you here. The techniques I show you are techniques which I use on a daily basis. Here we have a route which allows us to display all the books. Let's try to hit this route in Postman, and as you can see, it gives me all the details about the books. But let's do this. Let's here return only the title and the ID. And if a user will want to read a specific book, then we can do a select all. But currently we just want to display list of books, so we don't need to send all the data. We will have a specific route which shows us the whole data about a certain book. So here we go, this is our route, and in order to simulate a user reading a book, we will approach this route. Let's try to test this route in Postman. And as you can see, we managed to read this book. I will save it as well. Get a specific book. Okay, it seems like everything is working. And now I want that only an admin will be able to attach books to certain users, and I will make a check here which says that if a user doesn't have a permission to a certain book, he cannot read from this book. So we will check it later here, but first of all, let's make a route for the admin user, which allows him to attach books to each user. For that, we should make a new table as well. I will make it now. Create table user books. Okay. The first one is going to be ID serial primary key, and here we will make a simple join. I can do user ID integer references users and specify the ID column. Okay, and the third column is book ID, and here we will have the same join, but now we will point to the books table. Okay, books, and we should specify the ID as well. It seems like we are quite ready. This table shows us the relationship between each book and each user, and it will show us what books are used by each user. Let's execute this table. Let's try to do select all from user books in order to verify it. And as you can see, it seems like everything is working. Now let's start building our route, which allows an admin to attach book to a certain user. Let's create our route. Here we will specify the book ID. Of course, we will change it to post because that we are looking to insert data. And let's take the request data. We should make it be under the data variable. I can do request and do get JSON. And from here, I will extract the user ID. So we will get the user ID from the request body. User ID and data get. And there I will call it user ID. Let's just try to print it. And let's go to Postman and try to hit this route. Let's test this route. Okay, and as you can see here, we have the user ID. But before attaching this book to this user, we should perform a certain check. We should check if the book is available. So I can do cursor execute and do select available from books where ID is equivalent to our ID. So I will specify the ID here, and I can do response and cursor fetch one. So we should check if the book is even available before we are looking to attach it to a certain user. Let's print the response and just take a look at it now. We are looking to attach book number 2 to user with an ID of 1. Let's do it. And it says that available is true. We can make an if statement to check if book is not available, throw an error. So if book available not equal true, we can do return JSONify and return 400. Book is not available. So we can only attach books which are available. Here change it to be like this, so we should extract it based off the key. And here we just insert the values, and we call Postgres commit, we just call it once. After that we attach a new book to a certain user, we change the book availability from true to false. Let's change it to success, and now let's hit the route in Postman, and as you can see, it worked. We managed to attach book with an ID of number 2 to user ID number 3, and now let's try to do select all from user books, and as you can see, it works. Let's take a look and see if the book is still available. So we can do select all from books where ID is equivalent to number 2. And as you can see, this book is no longer available. Let's write a simple join, which will show us the whole data at once. So I can do select all from user books, inner join users on users.id equivalent to user books.user ID. Let's see if it works. So now we can see the users which are related, and let's see what books are related to each users. So we can do inner join books on books.id equivalent to user books.bookid. Okay, let's try to execute it. And it works. We can see the relationship all at once, but we shouldn't get all the data. We should get this. But we shouldn't get all the data. We shouldn't get the password and everything, only the username and the title. And now I will create a route which is used only for admin in order to view what books are related to each user. So it is going to be a GET request. I will copy it. And I will call it list user books. So I can do list user books. No need to specify an ID here. So I will remove it and I will call it list user books. It seems quite okay, and I will paste the exact same query. Here is our query, and now let's try to hit it in Postman. And as you can see, it works. Let's save this one, list user books, and we will call it admin only since it is used only for admin. Now let's make sure to enforce it. So this route is indeed only accessible by an admin user. As you can see here, we already have the user under the global variable, so we can extract it. We can do in the start of our request if g.user role is not equivalent to admin, return JSONify. You can access this route, and we should specify 401. Let's try to hit this endpoint again. Currently, I am not admin. And as you can see, this is what we got. You can't access this route. Let's make it look a bit more nicely. We should add the data key and send the request. And it looks much better now. Let's use this rule in other routes as well. This one is also used only by admins, so I will paste it here. Okay, and it seems like it is quite ready. This route is only accessible by an admin user. That's nice. Now, this is the route which allows a user to get a certain book, but we should make it extra safe before allowing to check even if the book exists or not. We should check if the user has this book in his inventory, so-called, because if the book ID doesn't appear here, it means that the user doesn't even have a permission to the book. So we can copy this statement and we should put it on the top of our function. I can do cursor.execute. I can just copy it like this. But first of all, we should also get the exact user payload. So I am looking to get the user ID, so I can do print g.user, which comes from this. As you remember, we stored the exact user payload under this global variable. And let's try to hit this route now, just so we can see what we get. Here we go, get a specific book. And as you can see here, we have all the user data. I am only looking to get the user ID, so I can extract it, user ID, and I will store it under a variable, user ID, and I will put it here. And now we should do this. We will change the query a bit. Let's go to Postgres and take a look at the results. We will do this. Select one from user books, where user ID is equivalent to 3, for example, and book ID is equivalent to 2. Let's try to execute this. And as you can see, if it exists and if the statement is true, it means that user ID number 3 has an access to book ID number 2. And that's the exact query we will use in our code. It will give us 1 if the results are good. And if there is 1, it means that yes, user indeed has access. If it doesn't give us 1, it means that user has no access. So let's try to check this route. I will just hit this. Oh, I forgot to turn on my API. And let's see, we got none. Okay, it means that the user doesn't have an access, so we can do if result equals none, we should return this, return JSONify. You don't have access to this resource. And we should return 401. Let's try to hit our route again. And as you can see, this is what we got. Let's make it look a bit more nice. We should add a key. And here we go. Currently, I am logged in as tester. So let's try to attach a new book to tester. Currently, tester doesn't have any attached books, but we should attach a book for him. Now tester has an access only for book number 4. Let's try to access book number 2, for example, just for seeing what it does. And as you can see, it says you don't have an access to this resource. Now let's change the ID of the book to book number 4. And as you can see, we indeed have an access to this resource. Take a look what we did till now. We managed to make a fully functional API with authentication, register, and login. We created routes and we made it in an organized way. There are protected routes, which are only suitable for admins. This thing is a fully functional API, and the concepts you have learned here are things that you will use in your real-world applications. Let's talk about error handling. In our Flask backend, currently we don't send the errors to the client due to security reasons, but there are some cases that you might want to indeed send the error to the client, the actual error. And in development environment, we indeed want to send it to the client, because that development environment, it means that it is an environment which I use to develop. So I am looking to see the errors in a clear way. But in production, no, I shouldn't send the exact error message to the client, because that it is quite dangerous. I can make an environment variable which will tell us if we are in production or development. So I can just call it Python env. And if it's in development, I can send the error to the client. If it is not, I shouldn't send it to the client. Let's just import it from .env, import log.env, so we can use the environment variables. I will call it here. And take a look at this. If we are in development, it will send the error to the client. Otherwise, it will just print the error and will send a general error message. Okay, let's try to hit it in Postman, and as you can see, we got the error. We simulated an error. I just removed something from the SQL statement. Let's fix it, of course. And now it came back to normal. Let's Dockerize our backend so that it is going to be optimized in production. Make sure to remove the debug through here and leave it like this. Here we have our Docker file. We set a work directory inside of the container, which is under the /app. Then we copy all the requirements, all our libraries, and we install them. Then we copy all the code into our container. And here it is used just for documentation, but here in the end we run it with this server, which is optimized and suitable for production. Of course, let's make sure that we also have our docker ignore file, and we are quite ready to build the image. Make sure that Docker engine is running, and we can start building our image. We can do docker and build and specify a tag. We will call it backend and specify dot. It will look for a Docker file in our directory, and we can just press enter. It will start building the Docker image. Let's do Docker images, and here is our image. And I can run it and specify the environment variables. I will change it to host docker internal because that currently this is how it can connect to my Postgres database, but in a production environment, of course, you will specify the IP of the database. So here we go, host docker internal, and let's run our image. Okay, let's go to Postman. And as you can see, it is working correctly, and now I access it from the Docker container. We can do docker ps, and it is running, as you can see, on port 5000, and I can access all the routes without a problem. Let's try, for example, to register. I will create a new user, and as you can see, it works. Now our backend is fully functional and optimized for production. In a production environment, of course, we will change it to production and we will specify the appropriate details, such as the Postgres IP. Kubernetes is a platform which allows us to run containerized applications and scale them automatically. Let's say that we have a web application with two services. The first one is the client and the second one is the backend. Let's use Docker in order to turn them into containers. Kubernetes will manage those containers. If one container fails, Kubernetes will lift him up automatically and will attempt to fix it. Our web application has two instances. The first one is the client, while the second one is the backend. In Kubernetes, each instance will run inside of a pod. So each container will run inside of a pod, and if a pod fails, Kubernetes will attempt to lift it up automatically. All of that is done in order to ensure 100% availability for our web application. So if we have massive load in our web application and we are in the middle of the night and something goes wrong, Kubernetes will know how to handle it automatically. In order to run Kubernetes on our platform, we should first of all install Minikube. But before that, we should make sure that we have Docker installed, because Minikube will run inside of a Docker container. Let's press here, and it will download it. Now we can just download it normally. Press OK and next, and let's wait for it to finish. Okay, now we can press next and finish. Now let's run PowerShell as administrator and copy those comments. Let's try to type Minikube now, and as you can see, Minikube was successfully installed. In order to start Minikube, first of all, we should open Docker engine. So let's open the Docker desktop application. Now it's ready. So the next step is to turn on Minikube. We can just type Minikube start. For the first time, it might take a while, but after doing it a couple of times, it doesn't take that much time. Let's wait for it. Okay, the setup is finished. Now let's do Minikube status. And let's try to execute a simple Kubernetes command. We can do kubectl, which is the command line from Kubernetes. It allows us to execute Kubernetes commands. So we can do kubectl get nodes. And as you can see, we got output for 2 of our commands. It means that our local Kubernetes cluster is working correctly and ready to be used. As you can see here, we also have our Minikube image and the container as well. Kubernetes runs on a cluster of nodes. Each node is just like a server, and then on each node we will have pods. Each pod will hold an instance of our web application, whether it's the backend or the frontend and so on. In Kubernetes, we have a thing called namespace. A namespace, after all, is just like a project. Whenever we want to configure a new web application in Kubernetes, we will create a namespace for it. Let's say that I have a web application which is called Torch. All the pods which are related to Torch will run under the Torch namespace. So first of all, I will create a namespace which is related for my project, and everything will be under this namespace. Let's create a pod. In order to create a pod in Kubernetes, we should use the declarative approach. It means that in order to create certain Kubernetes objects, we first need to define YAML files for them. Therefore, it means that if I am looking to create a pod, the first step is to create a YAML definition for the pod, and then after that I execute the YAML file, a new pod will be created. Take a look at this. This is the YAML definition file for a pod. A new pod will be created based off this YAML file. And as you can see, since Kubernetes works with Docker images, we have to specify the image. Kubernetes will go and pull this image from Docker Hub. So here is our web application. We have a client and a server. It means that we are going to have 2 pods. One for the client, while the other one is for the backend. Instead of creating a pod, a good approach nowadays is to declare a deployment, and based off the deployment, a new pod will be created. So instead of specifying a pod definition YAML for pods specifically, we should specify a deployment, and it will make sure to create a pod as well. Let's go over the YAML definition for the deployment. So as you can see here, we have the name of our container, and here we specify the image, and Kubernetes will pull this image from Docker Hub. Here we specify the port which was used in our application, and here we specify environment variables. So let's go to the code. And as you can see, here is our code, and we are using environment variables, as you can see here, but we exclude them from the Docker because that we are using Docker ignore. And when we are using Docker ignore, we exclude all the env files. So Kubernetes will make sure to inject our environment variables into the Docker image. So as you can see, here we use the connection string, which is indeed an environment variable for our backend. So as you can see, here we have the YAML file for our deployment, and this file will also create a new pod. So we can do kubectl apply and specify the -f. It means file, and we should specify the name of the deployment YAML file. Let's press enter in order to execute this YAML file and take a look at the output. Now we can do the following command: kubectl get pods. Kubectl is the command line for Kubernetes. It allows us to execute commands. Now the moment we do this, we will see all the pods. And as you can see, we managed to create a new pod based off this deployment YAML file. Now let's try to write kubectl get pods again. And as you can see, we have an error. Now in order to see more data about the pod, we can do kubectl describe pod, and we can specify the name of the pod. And as you can see, we already get more data, which is related to our pod. A good idea is to go to the pod logs. So let's clear the terminal. And it will allow us to know exactly what the error is. So we can do kubectl get pods, and we can type this kubectl logs and specify the name of the pod. And as you can see, here are the logs, and I can already tell you what is the problem. I will explain about it in the next video. Most of the time, when we are looking to fetch data, all what we do is specifying IP or a DNS. But in Kubernetes, in order to fetch data from our backend, we should use what is called a service. So we expose our backend via a service so other Kubernetes pods can reach it. So let's say that we have a client, and most of the time what we do in order to fetch from the backend is specifying the IP of the backend or the DNS of the backend. But this approach doesn't work in Kubernetes. So let's say that we have a backend pod, and this pod has a specific IP. If this pod fails, a new one will replace him, but the new one doesn't have the same IP as the old one, so in Kubernetes, addresses are dynamic. And also, each node has a different address and each pod has a different address. In order to solve this issue and reach our backend, we should create a service. A service will be our endpoint which allows us to access our backend pods. All the pods will be mapped to one service. Let's do kubectl get pods again. Kubectl get pods, and let's take a look at the logs. kubectl logs. And as you can see, our client code is trying to fetch data from the backend. We can see it here. It is trying to fetch data from the service called backend, but if we do kubectl get services, we can see that the service doesn't exist. So we should create a pod for our backend and also create a service for it so that our client will be able to communicate with it. The first step is to create a backend pod, and then we will create a service which exposes it. Take a look at our client. We first tell our client to fetch data from this endpoint, but whenever we dockerize our project, we exclude the environment variable. So this endpoint or file doesn't even exist. So we will fetch from the backend endpoint, and then in Nginx I say this. If we fetch from the backend endpoint, we will be redirected to the backend service. So as long as we approach this, it will redirect us to the backend service, and the config you see here is a real-world production config. So let's create the deployment for our backend. We can do kubectl apply -f, it means file, and specify the name of our backend deployment. Now we can wait a couple of seconds, and then we will do kubectl get pods. Let's wait for it to run. Let's write kubectl get pods again. And as you can see, our backend pod is running, and now we should create a service in order to expose this pod so we can reach this pod. So take a look at the service YAML. Here we specify the backend pod. So in order to attach this service to the backend pod, we should specify it here. And here we specify the port of this service. This is the port which we will use in order to reach this service. And then we have what is called target port. This is the port of the application itself, which is running on port 3000. So we map the application which runs on port 3000 to our service, which will also run in port 3000. So this is all what we have, and then we can do kubectl apply -f and specify the service YAML. So let's copy this and specify it here. Now we should wait for it to run. Here we have what is called type, and in Kubernetes, pods share the same network, so only pods from within the same network can access the backend via this service. It means that this service is completely internal. Now let's do kubectl get services. And as you can see here, we have all our services, and here is the backend service. And now we can do, first of all, I will clear the terminal, and I can do kubectl get pods. And as you can see, our client pod is running without any problems, because that now our client is able to fetch data from our backend, and is fetching it by specifying the backend service, which is called backend. And we can do kubectl get services again, and as you can see, here is our backend service. I also have another service which allows me to connect to Postgres from my backend. So as you can see here, I have a pod for Postgres, and I have made a service for it so that I can connect into it. And let's take a look at this connection string. This is the Postgres protocol. This is the username and the password. And here I specify the Postgres service along with its port in order to connect to it. And here I specify the database name. In a real-world production environment, of course, you will specify an IP address instead of this. And now the last step is to create a service for our client. And now I will use another type which is called NodePort. And this type will just create a specific port on all the nodes. And once we access this port, we will be redirected to our client. So let's do kubectl apply, specify the -f, and specify our client service. This thing is not used in production, but only in test environments. Okay, now we can wait for it to run. Let's do kubectl get services. And we can expose it. In order to truly expose it so we can access it in Minikube, we can do Minikube service and specify the service name. As you can see, this is our client, and we managed to establish a connection between the client and the backend, so the client is able to fetch data from the backend pod, and the client and the backend both run under the same host. So as you can see, if we go to the network tab and refresh it, you can see that the client and the backend, two of them, are running under the same URL. This setup is used a lot in production environments. A good approach is to keep the client and all the other services as cluster IP, and then all what we do is use an ingress which allows us to reach the client. So the ingress will expose the client and will redirect us to the client. In a real world use case, we will specify here an HTTPS certificate so that our client will be exposed via port 443 and will be secured, and we will also specify a DNS domain so that we will reach our client via a domain. When we are in production, we need to configure Nginx the same way as you see here. So our backend will be served from within the same client URL, so that the backend and the client, two of them, will be under the same host. This is a very good approach for production, and then once we specify an HTTPS certificate, it makes it easy for us because that we have everything under the same host. Take a look at Nginx. Nginx is a very good web server which allows us to serve websites. So this website is being served via Nginx, which runs inside of our container. As you can see here, I specified it via the Docker image. So let's go back to the Nginx configuration. And then we can use Nginx for proxies as well. So by the moment I will go to /back and Nginx will redirect me to the backend service, so I can do /backend, and as you can see, I see the API, and now I will do API /Todos. And as you can see here, I have managed to access my API. And instead of going to this directly, I have to go to it via Nginx, because this thing is private. So I cannot reach it from outside. But I can also reach my client from outside due to the ingress. So the client will proxy me to the backend. Currently, we were using Kubernetes locally with Minikube, but in a real-world production environment, we can use Rancher, which is a web UI which allows us to manage Kubernetes. We can see the status of the Kubernetes cluster, the different namespaces, the resources the Kubernetes consumes, and much more. There are also some cloud providers who offer us Kubernetes, such as Azure, Google Cloud, and Amazon. And if we want, we are not compelled to use Kubernetes. We can also use what is called a VPS, which is just a virtual private server which allows us to run our programs. We can just Dockerize our project and run the Docker image in the server. It all depends on your budget and your needs. If your application is massive, yes, Kubernetes might be a good decision. Otherwise, it is not must to run in Kubernetes. Knowing Linux as a developer is a very important thing. Quite often, you will find yourself using Linux, whether you have a problem with your pod or anything else, you will be compelled in the end to use Linux. Linux is everywhere, and in fact, most of the websites we approach today are hosted on Linux server. Whether it's Ubuntu, Fedora, or any kind of other distribution, it is in the end being hosted on Linux servers. Let's start learning about Linux. We can explore Linux and use some basic commands. For example, I can do the dir command or ls command, and it will display all the files and folders under the current directory. If I want to see my current location, I can type pwd and it will display it. If I want to change directory, I can use the cd command. It stands for change directory, cd, and specify the directory we are looking to navigate to. We can do cd/bin. And take a look at all the files under the bin directory. Here we shouldn't touch any of those files. Those are system utilities. For example, you can find a lot of system commands such as ls and much more. We shouldn't touch this directory because it provides a lot of system utilities such as SSH and much more. Let's go back. In order to go back to the previous folder, we can use the change directory command and specify dots twice. So we can do dot and another dot, and it will redirect us to the previous directory. We can use the clear keyword in order to clear the terminal. Let's say that I am looking to create a certain file. I can use nano in order to do that. And let's create a Python script. For example, I can call it script.py, and here I will just print hello world. Okay, now I can press Ctrl and X, and I should press yes and enter, and it will create this small file. Currently we have permission denied. Okay, so we can go back and we can use the sudo command, which will execute our command as a root user, and it will bypass this limitation. So I can do sudo nano script.py. Now I will specify the password, and here I can do the exact same thing. So I can do Python script. Let's save it now, and as you can see, it is working. Now we have our script here, and we can use the cut command in order to see its content. As you can see, here is the content of our script. In order to remove this script, we can do sudo rm script.py. Let's try to do ls again, and as you can see, the script is not here anymore. Now, in order to create a directory, we can do make dir and specify the name of the directory. I can call it test. We got permission denied. Okay, let's use sudo again. And as you can see here, we have our new directory. And now in order to delete the directory, we use rm, but we also specify the dir. It stands for directory, and we specify the name of the directory. Again, permission denied. Okay. Instead of getting the permission deny every time, I can just connect as a root user. I can do sudo and specify the -i. And now I am connected as root. I can execute whatever command I want without limitations. We can go to the etc folder. In this folder, we have configuration files. We can navigate again to systemd, and here all what we have are configuration files for services which start after that we boot. Here you can take a look at some Linux folders. Here we also have the boot folder. We shouldn't touch this folder because this folder is responsible for the boot files which allow our server to boot. Let's talk about storage a bit. We can press the df-h in order to see all the storage in a readable format. And as you can see, we start from the root, and this is the overall storage we have in our Linux. It means that we start from root and we have almost 10 gigabytes. We can use the lsblk to list block devices. It will list all the storage devices we have. If we plug a new drive and it is not mounted, we can still see it here, and based on this, we can add this storage to our system. Let's say that we are in a pod and we would like to test the connectivity from our point to a certain endpoint. As you already know, pods, containers, and all of those things use Linux. So we can use the curl command. Let's create a basic request to a simple website, https example.com. And as you can see, here is the result. And it means that we managed to connect to this website. So there is a connection, or in other words, a communication. It might be a useful thing when you want to see if your pod has access to a certain endpoint. In order to install things in Linux, we can specify the sudo apt update, and then we should specify the thing we want to install. In our case, I am looking to install nginx, so I can do sudo apt install nginx, that's the command, and now we will let it run. Let's wait for it to finish. Okay, we should get out of this folder. And now we can do systemctl status nginx. It will allow us to check the status of the nginx service. And as you can see, it is active. I can also stop the service if I want. I can do systemctl stop nginx. Or I can also start nginx. And if I want to make it run after a restart, I should do enable nginx. We can use the cat command in order to see the nginx configuration. This time we can just specify the command and also specify the path. So do you remember that in etc we have configuration files? So we can do etc/nginx and specify the file name, which is nginx.conf. And take a look, here we have our configuration file for nginx. Nginx is also a widely used web server. In the end, we should provide a file to nginx, and nginx will serve this file. Nginx by default runs on port 80, so we can do curl and specify localhost. And as you can see, this is the nginx webpage. Let's continue our navigation. I will exit from the root user. Now we can do cd/home, and we should make a directory. Here I can do make dir. I will make sure to add sudo, and I will call it scripts. Let's do ls, and as you can see, here is our new directory. It is not recommended in a real server, but just for the example, in order to give permissions for anyone who wants to write into this directory, we can use the chmod command and specify 777 and our directory. And now let's do ls-l again. Now we can do the same thing for the scripts directory, but we will have to use sudo. So take a look, sudo chmod, and we gave permissions to the scripts directory. Let's do ls-l again. And now, as you can see, everyone can execute files into this directory, read and write files, all the users in the Linux server, and it is definitely not recommended, especially if there are a couple of people who use the server. That's why you should never do it in production. But let's just try to copy a file into it. So here I have my text file, and I will just drag it. And as you can see, it is working without a problem. Here we have the new file. Sometimes you will try to communicate with other servers and your server can throw an error which says that the server doesn't truly trust the server you are looking to communicate with. In this case, you can go here to the certificates folder and you will download the certificate of the website you are looking to communicate with and you will put it here so your server trusts it. Sometimes you might want that apt install will install files from a certain endpoint. Let's say that your organization has a certain place for downloading packages and you want to configure your Linux server to download from there when you do sudo apt install. So in order to make it automatically download from there, we can use this command. Here we can add our endpoint and from this endpoint apt will install. In order to edit this file, you can just change it from cat to nano, which allows you to edit files, and I can add sudo here and just add your endpoint and save it. Let's take a look at the nginx configuration file. We can do cat etc nginx/nginx.conf. And as you can see, we have a lot of things here. What if we are looking to search a specific thing? Then we can use grep for that. So we can do this, grep, and specify the string we are looking to get. In my case, the string is server. Let's press enter now. And as you can see, we got it. Here we have server a couple of times. Imagine that you have a massive file with hundreds of lines and you just want to know what is a specific value. Then you can just use grep along with this value and it will give you the results. We can use the whoami command in order to see the current user. And let's change to the root user now. Sudo I will type the password and I will use this command again. And as you can see, it displays the root user. We can type this in order to see all the processes. As you can see, each process has its own PID, which stands for process ID. In computer science, each process is completely isolated and has its own memory space. In order to see your IP and your network configuration, you can type IP and specify this, or you can just specify A, which is a shortcut for address. You can use the man command in order to see data about a certain command. Let's say that here I have the ls command. If I am looking to see data about this command, I can use this command and it will show me a man page of this command. This is a thing which has all the data towards a certain command. I can specify other commands as well. Let's try to take a look at the fork command, which allows us to create processes. Man fork, and as you can see here we got some data towards this command. In order to see the history of our commands, we can navigate with the arrow keys, or we can specify history and it will show us the history of our comments. Let's take a look again at the man page for the fork command. In order to take a look at a specific keyword, we should use the grep. So here is a very realistic use case of the grep command. Let's just write the keyword thread. I am sure that this keyword will exist. And as you can see here, we got the results. Threads and processes are quite very interesting things in computer science. Each process at least contains one thread, and there is communication with threads because that they share the same memory within a single process. It is a very fascinating topic. I recommend you to go and read about it. We can use the touch command in order to create a file. Let's create a simple text file, touch test, and we should use the text extension. And now we can edit this file with nano. I will just write hello world here and I will save it. Now let's do cut. And as you can see here, we got hello world. Let's take a look at all the processes again. We can type this command and let's go to the top. In order to stop a certain process, we can use the kill command and specify the process ID, which is called PID. It will terminate the process. Please make sure not to accidentally terminate important processes. It can cause damage to your server. And of course, once again, you can use the grep command in order to look for a certain process. So let's take a look at the Nginx process. And here we have all the processes which are related to Nginx. In order to see the system usage, such as CPU usage, memory usage, you can write top. If you want to see it in a better format, then you should write htop. In order to see some data about the operating system, such as the kernel, you can use the uname. If you want to see it with more details, you can specify the uname-a and it will show you more details. You can use the double dash on a certain command in order to get help. So take a look. We can type ls-help and it will give us info related to how to use this command. There are a lot of processes in Linux, and let's take a look at the Nginx process. So I should do grep and specify Nginx. Here we have all the Nginx processes, and Nginx is a daemon process. It means that it runs quietly on the background, but whenever you open an application, for example, the process is not a daemon because you can see the process and is not running quietly on the background. So take a look at this Docker image, for example. Here we run Nginx, and in this Docker image, Nginx is not a daemon. It means that by the moment you go to the pod, all what you can see is the Nginx logs, because it means that Nginx doesn't run quietly in the background. For pods, it is a good decision because that you are looking to see certain logs whenever you access the pod without having to navigate directly to Nginx. So by the moment you will log in and go to the execute shell option, you will see it immediately. All what you will see is the Nginx logs. You can use the echo keyword in order to print something to the terminal. So we can do echo hello. Now the second thing is that we can make a bash script with nano. So let's do it, nano, and we should call it script sh, which is the bash extension. And now I will print this command here, hello. And I will also say this is my bash script. Now I will save it and let's try to run it. Bash script.sh, and as you can see, here is the output from the script. Let's try to edit our script again. We can do nanoscript.sh and I can do it like this. This is my bash script. I modified it now. Take a look down here. As you can see, it says save modified buffer. A buffer is a certain region at memory which allows us to temporarily do certain things, and once we save it to the disk. So we make a syscall in order to save our data, which is located in a buffer somewhere at memory, to the disk. So we can press yes. A syscall, or so-called system call, is what the operating system does whenever it needs access to the computer hardware. Currently, we were looking to write data to disk. So the operating system asked the kernel for access, and the kernel gave access to the disk, which allowed us to save the modified buffer from the memory to disk. Applications run in user space and a kernel space. In user space, they don't need to do system calls, they are just working normally, but whenever they need to access certain computer hardware and do certain important things, they can move to kernel mode and ask the kernel certain things, such as writing to disk, loading a file, and much more. Kernel is important because that without a kernel, everyone would be able to access hardware resources, and it can cause a lot of bad issues. When there is a new process, the operating system allocates memory to this process so that the process can function normally without any problem, and that the process will have all what it needs in order to run. But the main thing here is that processes don't directly communicate with real memory. All what processes have is called virtual memory. It means that the operating system gives them an abstraction, so they don't point to direct memory addresses because that it is quite not safe. All what they do is point to virtual memory, which is mapped to real memory addresses. Then we have an abstraction which makes things much more safe. And as I said before, each process has its own memory address and also its own process ID. And also each process has its own regions of memory, such the stack or the heap. Those things are more related to low-level developers. It is related to people who develop in languages such as C. The average C developer will not deal with the stack, for example, since the stack gets handled automatically. The stack is more likely used whenever you use functions or function parameters or things which are related to the scope of the function. So the average developer will not have to deal with all those things, even with using C. Whenever you need dynamic memory allocation, then you will use the heap. The heap is used for borrowing memory, and then you can declare an array with this memory and do much more things. But it is quite dangerous because that if you will forget to free the memory later, you can cause memory leaks and a lot of issues. Those things are not necessarily related to Linux, but it is nice to know. It is related to low-level development or kernel development or driver development, a lot of things which are indeed in the Linux ecosystem. But nowadays, due to languages such as Java, TypeScript, Python, C#, and more, we don't have to deal with those things. It is nice though to learn. If you are interested in those things, it can give you a good knowledge towards how programs used to be back then. Currently, I am using Ubuntu, as you can see here, but Ubuntu is just a Linux distribution, and Linux is a kernel, is not an operating system. There are a lot of distributions who use the Linux kernel, such as Fedora, CentOS, Ubuntu, but Ubuntu is widely used within web servers nowadays and within Linux servers in general for automations, workflows, and much more. If you are looking, for example, to deploy an automation, then using a Linux server, such as Ubuntu, for example, can be a very good decision because that it is quite simple. And also, Linux doesn't consume that many resources, so it is optimized for such tasks. And let's say that you are looking to deploy a service, as we said before, then you can go here, you can go to the etc directory, and here you can do cd systemd, and here you can declare services and make them run. After that, the system will restart, so you can make them run automatically. Monitoring your Linux server is also important. You should know what is going on in terms of CPU usage, memory usage, and everything. You can use, for example, a Python script with a certain library, which gives you all those details, and then you can monitor your Linux server by just sending the results to an API, or you can deploy certain things, such as Prometheus, node exporter, and much more. Then you can visualize it in Grafana, so the possibilities are truly endless. In order to practice Linux, I truly recommend you to go and download the VMware Workstation. It will allow you to use virtual machines, and you can use any operating system, whether it's Fedora, CentOS, Ubuntu, and even Windows, which is not Linux, but still you can use any virtual machines. And then you can also download the MOBA Xterm software. It will allow you to SSH into the server, and it will allow you to use the server in a very nice and comfortable way. You can copy things to it, you can do much more things, and it is very comfortable. In order to download the Ubuntu server I currently use, we should go to Google and we should type Ubuntu server download, and let's press on the first link, and here it is. This is the server I am using. After that, the download is finished. All what we will have to do is to open the VMware Workstation and specify the ISO image, and then it will create the virtual machine for us. in order to download VMware, you should type this VMware Workstation, and you should type download, and you should go, you will sign in, and it will let you download it. Now let's see how we can download the MobaX term software. This is the software which mainly allows us to SSH into our server and interact with the server in a comfortable way. We can copy paste and do all kind of things. So let's type MobaX term, and now we should go here. We should choose the free version. It is a very good version, and we can use the portable edition. We will wait for it to download. As you can see, here is our download. We should extract it. Okay, and here is the software. We can press on it in order to run it. It will open up in a couple of seconds. And then I love to pin it to the taskbar and also change the theme to dark. And in order to log in, you should press sessions. And here you can use the SSH option. This is the option I use. And you should specify the IP. I will just make a fake IP. And here you should specify the username of the server. So you can call it whatever you want, whatever is the username you have. And then once you press OK, it will attempt to log in. It will ask you for the password of the server, and once you put it, it will let you access it. And here you can rename the server. You can change it to guide, for example, or you can call it whatever you want, for example, backend server. And it will also ask you if you want to save the password or not. If you save the password, then you can just connect to the server by pressing here, and it will connect you automatically. Currently, our development process was local. A good idea is to use Git along with GitHub so that we can save our code in the cloud. Git will allow us to save our project and then upload it to GitHub. So let's first of all download Git. I can type Git, and here I can go to the download section. I will press on it, and let's choose Windows. Now let's press here. We should click yes, and all what we do here is just pressing next. And now all what we have to do is wait, and we can press finish. We can press right click and press on show more options, and then as you can see here we have Git installed. We can open its terminal, and as you can see we are using Git without any problems. You can also access it from here, Git bash, and then it will open it. And the Git is an amazing tool which will allow us to push our code changes to GitHub. Using Git by itself is not enough, of course. We should also use GitHub. Git and GitHub, they work together. So let's first of all go here, and we can type GitHub. We can press on the first link, and the first step that we are going to do is to sign up and just fill the relevant data in order to create your user. You can fill those values, or you can just sign up with Google. Okay, we managed to sign up. Now all what we need to do is to link Git to GitHub. In order to do that, we can press here and type git bash, and we should copy the following lines. The first line is this. We should specify our username. And then the second line is this. We should specify the email which was used for our GitHub account. And then we are all set. Let's see how we can save our project in GitHub. So as you can see, imagine that this is our project. Currently, it only says hello world, but imagine that this is a complete project. Here, backend is our project. The first thing we should do is open a repository in GitHub. We can press here and press on repositories. Let's create a new repository. We can call it guide example, and I will put the description as well, the same as the title. Here we can choose whether the repository is going to be public or private. Meanwhile, I will leave it to be a public repository, and we can just press create repository. Let's link our project to this GitHub repository. So let's open it in VS Code. As you can see, I already have it here. The first step is to type git init. It will just declare it as a local repository. We should press enter. Okay. And now all what we need to do is to copy those steps. So let's copy the first thing and the second one. And before copying the third command, we should do this. Here we have our new repository, but first of all, we should store all our changes. So we can do git add, and we should create a commit message. This is our first commit. Whenever we change our code and push it to GitHub, first of all, we should add the changes to the staging area. And then we should create a commit message which will explain all the changes. I can just specify it as my first commit. So the command is git commit -m. And here we specify the commit message. I can just call it my first commit. My first commit. Let's press enter. And now we can copy the third command, which will push our local repository to GitHub. Let's press enter. And it will ask us to sign in into our GitHub user. It will only ask us once. After that we do it. We don't have to do it anymore. After that we can go back to GitHub and see our new repository. As you can see, here is our new repository, and if we click on it, we can take a look at our code. And let's say that now I am working from a completely different computer and I want to have access to my code. I can do what is called git clone in order to keep working on my project from another computer. So let's do it. Let's remove our backend folder. I will remove it completely. And here I will open git bash and I will specify this command. I can do git clone and specify the repository URL. So let's do it. We can press here and copy this. And as you can see, here is our project. We can open it. And let's try to make a new change to our code and push it to GitHub again. We have green lines here. It means that there are some changes in our code. Let's print my second commit. And all what we do now is opening a terminal. We should add those changes and we should specify our commit message. I will call it my second commit. My second commit. And all what is left for us is to push it to GitHub. We can type this git push origin main. And it will push our changes from the local repository to GitHub. Take a look at our repository again. As you can see, here are the changes. Let's talk about Git branches. You can imagine branches as different versions of your code. So if we type git status, as you can see here, we are on branch main, and it means that this is our main branch. It means that this branch is the most important, and here our code is the most optimized code, which is ready for production and much more, and only good code should be there. Let's say that I am looking to test certain things or create features. Typically, I wouldn't want to work directly on the main branch. Let's say that I am looking to implement a feature which is used for logs. Typically, I will deliberately create a branch which is used specifically for logs, and I will update my code and save my code there. And once the feature is ready, I will merge it to the main branch. So let's create a new branch. We can type this git branch logs. And in order to start working on this branch, we can do git switch logs, and we can type git branch in order to see all our branches. Here we only have two, which are logs and main. And currently we can type git status in order to see on what branch we are. And currently we are on branch logs. So we can start working inside of this branch. I can print or maybe create, imagine that this is a completely new feature. I will call it feature related to logs. And imagine that in this branch we have a certain functionality which is related for logs. And now, once I am inside of this branch, I can do the same things I did back then in order to save my code. So I can do git add, and I can type a commit message, git commit -m, and I will just call it new logs feature. There was a spelling mistake. Now let's press enter again. And all what I need to do now is to type git push origin, but now I will not specify main because we are not working on the main branch. I will specify logs, which is our newly created branch. And as you can see, we managed to push it to GitHub. Take a look at our repository. Here is our new branch, and you can see that we have two branches. And now if we go back to our code and we switch to the main branch, we will not see our logs feature because that we haven't merged it already. So now we should do it so that it will be on the main branch as well. I can copy it here also, and I will create a pull request. And now I can press on merge pull request. Let's go back to our code. Currently, we are still on the main branch. Let's do git status. As you can see, the branch is main as well. And now we just need to pull the changes. So I can do git pull origin main. So I can pull the updated code from the main branch. And as you can see, here is our feature. We had to create a new branch which is specifically used for our feature. Then we pushed it to GitHub. Once the feature was ready, we managed to merge it from our logs branch to our main branch. And as you can see here, we can visually see it. Take a look, this is our main branch. Then we managed to create a new branch which is related to logs, and we built our feature there, and then we merged it into the main branch. So now all the changes appear inside of the main branch, which is our updated branch, which is ready for production. Working with branches is a core thing which is used with a lot of projects. As you can see here, this is a serious project which I have, and I am using branches all the time. Let's check some useful comments. We can type git status to see our current status and to see on what branch we are working. Another good command is git log. It will show us the whole history of our commits. Another nice command as well is the git restore. It will allow us to go back and revert changes to the last commit. For example, let's type git status. Currently, we don't have any changes. Let's just create a small change. I will just type change. And now let's do git status again. As you can see, it tells us that our change wasn't added to the staging area and was not committed. So I just can go back to the previous state. I can type git restore and specify dot, and it will revert the change and will let us go back to the last commit. Back then, we were using only one single backend. But what happens if the backend fails? Then it means that we no longer have access to our web application. But nowadays, a good approach, especially in microservices, is to use an API gateway. So instead of reaching a single backend, we will approach the gateway, and the gateway will redirect us to the services. So take a look here. I first approach to the API gateway, and the API gateway will redirect me to the desired service. Back then, if we only have one backend and the backend fails, we no longer have access to our web application. When we are using an API gateway, if one service fails, it is still okay because that we still have access to the other services. So take a look here. I have 3 services and 1 gateway. So service 1 is this, service 2 is this, and service 3 is this. All of them have the same endpoints. And now let's try to reach them from the gateway. In order to reach service number 1, I should specify the name of the service, and the gateway will automatically redirect me to the endpoint of the service. So let's try to reach this service, and let's specify the hello endpoint. So take a look, the gateway is running on port 5000, and now I should hit this endpoint. So I should do API/service1 and specify the path, which is hello, as you can see here. Let's try to hit this route. And as you can see here, we managed to connect to service 1 from the API gateway. Now let's change it to service 2, for example. And as you can see here, we are at service 2. And now let's go to the last service. And as you can see, we are in service 3. If your application is using the microservices architecture, using an API gateway is a very good idea. Just like how we use Postman in order to interact with our APIs, we can use Python as well. So let's take this link and use the requests library in order to interact with our API directly from Python. Let's declare a function, we will call it HTTP, and in this function we will send our HTTP requests to the API. Okay, and now I will start using the requests library. Let's start. So as you can see, I can use a couple of methods. I have the get method here, I have the post method, as well as the patch and delete. Currently, we are looking to make a get request, so let's specify the get method, and let's copy our API endpoint. Okay, and now let's try to look at the API data directly from Python. I will call the JSON method in order to view it as a JSON, and I will print the data. Let's call our function, of course. Let's open a new terminal and type Python script.py in order to execute our script. And as you can see, here is our data. So it means that we can communicate with the API directly from Python and not by using only Postman. We can use other methods as well. We can use the status code method in order to check the status code of our request. Take a look. Here we have 200, which says that everything is okay. Let's try to take advantage of other methods as well. Now we will try to send a post request to our API directly from Python. As you can see, now we can use Postman in order to send the post request. But currently, I would love to use Python. So I will declare the structure of the data we are looking to send. I will call it body, and it's going to be an object. Here we have our data. And here we have our headers. In order to send a post request, we should mention headers. And now let's try to send our data. We should specify the JSON keyword. And here we will mention our data. And we should specify our headers. Okay, let's try to execute this script and then take a look at the status code of the request. I can do script.py and write Python in order to execute it. And as you can see, we got 200. Let's try to send the GET request again. And as you can see, here is our data. Okay, now let's use the other HTTP methods. We will start with the delete method. Now I will change it to delete and I will remove this one and this one because that it is not needed now. We are not going to send anything. We are just going to delete an entity. And now I will specify the right route. Okay, let's take a look at all of our to-dos again. I would love to delete to-do number 7. Let's try to run our code now. Let's send the GET request again. And as you can see, to-do number 7 doesn't exist. Let's make a patch request now. Let's use the correct route first of all. We can take a look at the to-dos again. I would love to change to-do number 2. Okay. And let's change the title. I will only change the title. We can call it using patch request. 1 second. Using a patch request directly from Python. Okay, it seems quite good. Let's use our headers again. And now let's specify everything. JSON, and let's specify the body and our headers, of course. Okay, and let's try to run it now. Okay, we got 200. And as you can see, here is our new modified to-do. You might ask yourself, why is it needed? But imagine that you are looking to monitor a specific endpoint. You can use the requests library in order to check whether this endpoint is up or down. Then you can save the results to a database such as Postgres and transfer it to Grafana for real-time monitoring. Remember that building reliable backends isn't related only about development, but also about continuous monitoring. And for that, we can use tools such as Zabbix or Grafana for real-time monitoring. Connecting Postgres to Grafana is quite easy. First of all, I am going to make a new database, so I can call it create database, and I will just call it guide. Let's do /l in order to display all the databases. And now I am going to use our guide database. I will clean the terminal and I will do dt in order to display all the relations or so-called tables. And now here I will create the first table. Create table to do. I am just creating it for the example. ID is going to be like this, primary key. And the second column is going to be title of a type text. It seems like we are quite set. Let's take this and execute it here inside of Postgres. And as you can see, here is our new table. I will select all from it. We don't have anything inside of this table, so I will insert data, insert into to-do. Let's specify the column, and then I will specify the values. To-do number 1. Let's execute this inside of Postgres. And then I will add another to-do, which is to-do number 2. And now I will do select all from to-do. And as you can see, here are our new created to-dos. Okay, so we have Postgres installed, and we have a database and a table inside. So it means that we are almost there. All what we do now is to go to the data sources section. Here, as you can see, I already configured Prometheus. But now we are interested in another database, which is Postgres. As you can see, those are a lot of options. We can choose all kinds of databases. For example, InfluxDB, which is a very nice time series database. But as I said, we are going to select Postgres. So let's press on it. And now we should write the port and the URL. So localhost and its port. The database name. In our case, the database was guide. And the credentials for the database. In my case, the password is Postgres. And also the username. We can disable it. And let's try to test it. So as you can see, it means that our database connection is okay and that we can start building dashboards which are related to Postgres. In order to add the dashboard, we can go to the menu and to the dashboard section. Here we can create a new dashboard. Let's call it Postgres. I will call it Postgres dashboard. And we can make it like this, a dashboard which is related to the Postgres data source. Okay, and in order to come back into this dashboard, we can go here and press our dashboard, and let's start interacting with our database. We should select our data source, and as you can see, we can write any kind of queries. So I can do select all from. Let me try to increase it so that you can see it better. From to do, which is our table. And now we should select an appropriate panel. So as you can see, here we have all kind of panels, and it means that we were successfully interacting with our database. In order to make sure that our website stays secured, we must configure it to use HTTPS. It makes sure that our website is secured, and if we don't do it, our website will be flagged as unsecured and will be not secured at all. Imagine that here we have our website, here we have the client, and here on the right we have our API server. Let's say that someone sends any data from our website to the API server, to the backend. If we don't use HTTPS, it means that the data is not even encrypted, and the hacker which sits in the middle can grab this data and do malicious things with it. That's why we should always, as our first priority, configure HTTPS via certificates. When using HTTPS, we have two methods. The first one is called symmetric encryption. It means that we encrypt the data and then we send it to the server, but we also send a key which allows us to decrypt the data. Nowadays, this technique is not used widely because that if a hacker sits in the middle, he can still grab the key which allows him to decrypt the data. Because that by using this technique, we are sending two things at once. We send the encrypted data and the key which allows us to decrypt it, which is not good. The best approach is to use asymmetric encryption. In this approach, we send the encrypted data, but we don't send the key which allows us to decrypt it. The key stays on the server, and by doing it, it makes it much more secured. If a hacker will be able to grab the encrypted data, but he will not have the key, he cannot do anything with it. You might think that it's enough, but the truth is, it is not. A hacker can sit in the middle and do what is called man-in-the-middle attack. You will think that you are communicating with your API, but the truth is you will communicate with the hacker web server, and you don't want it. That's why, in order to solve such an attack, you should use a certificate from an authorized CA. CA stands for Certificate Authority, and whenever you want to configure HTTPS for your website, you need to use certificates, and you can only get a good certificate from a known certificate authority. If you will generate your own certificate, the browsers will not consider your website as secured enough and will flag your website as not secured. How do websites stay secured? What is the difference between encryption and hashing? Those are the questions I am going to answer in this video. In every website, a login page is the first form of security. And as you can see here, we have a simple register page and a login page. So first of all, we can create a user, for example. Let's just call it tester. This is just a simple website I have made. Nothing too fancy about this website. And then we can sign up. And now we can log in with the same credentials. The password is also tester. And let's sign in. Okay. And now I would love to show you what is going on under the hood. Each website has a database in order to save all the data, for example, the user's data and much more. So let's go and take a look at the database. Here I have Postgres, which is my favorite database personally. And now I can do /dt in order to display the tables. And as you can tell, the user's data is being saved inside of the users table. So we can do select all from users. And as you can see, here is our user. So this is the user we just created, which is called tester. And take a look at the password. You might ask yourself, what is this? Because our password was tester and not this long string. And that's the catch. You should never store plain passwords inside of the database. As a web developer, you should always assume that at some point your database is going to get hacked. And therefore, because of that, you cannot store a password as is. And here comes the question, what happened to this password? What happened to tester? How did tester turn out to be like this? Is it encrypted or hashed? And this is where I am going to explain the differences between encryption and hashing. In our case, the password is hashed, not encrypted, because that encryption always comes with decryption. But in our case, we cannot turn this string back to tester, no matter what we do. But when you use encryption, it means that you can use a secret or a certain key in order to turn the encrypted data to its original state. But this is not our case. No matter what we will do, once a password has been hashed, we cannot go back. And now I would love to go to the backend itself in order to show you what is going on under the hood. So as you can see, this is the function which is responsible for registering users and saving the data inside of the database. And once we specify a password, this line is responsible for hashing the password so that the password is not going to be saved as is. And as you can see by this line, we insert the hashed password, and we are using a very nice library which is called bcrypt in order to hash our password. Hashing our password turns the normal password from tester to this long string. But then you might ask yourself, how does it work? I mean, how can a user log in if the user specified tester as a password, but the actual password is hashed? It is not tester. And in order to log in, there has to be a comparison between the actual specified requested password and the password in the database. Okay, so I will log in and then I will show you what is going on. So here is our name tester and the password is also tester. And what is happening is this. First of all, our backend, this function is looking for a user with a username called tester. If it doesn't find one, it will throw an error, and then it does this. If it finds a user called tester inside of our database, it gets the password we specified here in our login form, and then it does hashing on this password, and it compares it with the hashed password which is already inside of the database, because that it cannot compare tester as is with our hashed password. It has to hash tester again in order to make a comparison between the two passwords. If the passwords are the same, we generate a token for the user, and in order to access the web application, the user needs to have a token, because that our routes are being protected by a middleware which checks for a token. If the token has been verified correctly, the user can access our web application. And as you can see here, this is the middleware which checks for a token, and then the token itself has data about the user. So you can extract the user ID, the user role, and everything which was included inside of the token. In our case, the things which were included are username, user ID, and user role. And as you can see, in our routes, we call the middleware before going to our other routes. So if the token has failed, a user won't be able to access the routes, the API routes, and the website itself. Modern website security implementations are nice but not good enough. Most people secure their websites by hashing passwords and using JWT token in order to prevent access to the website and the API, but a lot of them forget something which is very important, and by doing it, they leave their website open to a side channel attack which a skilled hacker can exploit easily. Today I am going to show you how you can fix this security flaw and how a hacker can exploit it from his point of view. Here we have our login page, and we can also register. So everything is okay, because that once we register, take a look. Now the password is being hashed inside of the database, so we can do select all from users. And here is our new user. So this method is a modern web security method, because that you cannot save plain passwords into the database, right? So we are using a modern web authentication method, and now I will go to the code which is responsible for doing it. It is inside of the authentication controller. And as you can see, this code is responsible for registering users. All what we do here is hashing the user password and then storing the hashed password into the database. And here, whenever someone is trying to log in, there is a comparison between the requested password and the hashed password which is already inside the database. If there is a match between the two passwords, it means that the user is going to get a JWT token. So it seems quite legit. The user logs in and then he gets a token, and in order to access our web application, he needs to specify a token. Without a token, he will not be capable of going into any of our API routes. So it means that in some way our website is secured, but not secured enough. And now I can show you how a skilled hacker can exploit this code. Okay, and now let's try to log in with a random user. So for example, we can just call it random_user, and then we can just call it random password. So I will change it to random password, and I will copy it and use this thing as a password. And of course, we don't have any user which has those credentials. And now let's do sign in. And here a skilled hacker can take a look at the API request. So now let's type it again, and let's change it from random user to password. I will call it random password and use it as the password. And now let's take a look at the API request. As you can see, this is our request. So let's go and write our API URL for authentication, which is this. And now let's take a look at the payload. So this is our request body. This is all what we send into the backend server from our client. And if we go back to our authentication code, we know that what is happening under the hood is that we check if the user exists, first of all. And then we compare the passwords. We know that if we log in and the user doesn't exist, we will get an error. And we know that if the user exists, there will be a comparison between the passwords. And it means that we will move to the second stage. So a skilled hacker can try to log in with all kind of usernames and see what username takes the most time to get a response. So let's say that I am trying to log in with all kind of names. So for example, I have a list of certain names here. All of those are random names, but I know that admin exists. So for admin, we will move to the second stage. And because of that, it will take much more time to get a response from the API in comparison to the other users, which do not even exist. So let's do DT in order to display the tables. We can do select all from users again. And as you can see, admin exists. And because of that, the time it is going to take for us to get a response for the user admin is going to be higher than the average time it takes for other users with different names. So let's go and try to make a code which is going to emphasize it. So I can now import the request library, and also I will import the time library in order to measure how much time it is going for us to get a response from the API. And I will make a function which is called HTTP, and this function is going to accept username as a parameter. And now I will use try and accept, just so that if there is an error, we will throw an exception, accept exception as error, and then I will print the error. So first of all, I will also import all the usernames we have. So I can import our list, and then we will iterate over this list and use our function for each username. And now I can start building the request structure. For example, body, as we can see here, the request body is this. We have the username key. And now the username is going to be the username we specify in our parameter. And the second key is going to be the password key. Okay. And the password is going to stay the same. I will just call it random password. Okay, it seems like we are all set. And now we can move on and send our response. So I can do response request.post. We make a post request, and I can specify the URL for our authentication. This is our API route. And now I will specify the data, JSON, and now I can specify our request body. This is the data we are going to send. And let's take a look. Okay, and now we can do this, print. Let's do it like this. Sorry, there is a small mistake. The time it takes for user, and now I will specify the username is, and now I will specify the response time. So let's do start time equals time.time. I think we can call it like this. And then I will do end time equals time.time as well. And now I will have a variable which is called total time. And this variable will show us how much time it took for us from the start to get a response from our API. So I can do end time minus start time, and I can specify the total time here. Okay, so let's take a look and see if everything is okay. The time it takes for username is okay. And we can even maybe specify the status code. Status code is okay. And now we can specify the response status code and also the response text. Why not? Okay, let's take a look. It seems like we're quite good. Everything is in its place. And now let's iterate here. I should call it usernames. For username in usernames, I should call our function and use a name as a parameter. So I can do username. Let's take a look. And to me, it seems like we're quite ready. Now let's open a second terminal in order to execute this code. Okay, so there is a small typo. We should call our time function like this with brackets. And now let's try to run our code. And as you can see, here are our results. And let's see the time it takes for admin. So I will try to make it bigger. And the time it takes for admin is much higher than the other times it takes for other users. So as you can see, because that admin exists in our web application, it takes a lot of time for admin because that in our backend, once we specify admin, we move to the second part. And when we use users which don't exist, we don't move to the second part. So a hacker can just specify a lot of names and see what kind of names have the higher response time. And based on that, he can know what users exist and what not. This thing is a side channel attack because that a hacker shouldn't know what users exist, because that otherwise he can make a brute force. For example, once he knows that admin exists, he can make a brute force and try to specify random passwords in order to log in into admin. So this is a side channel attack which modern implementations in most cases don't cover or forget to cover. Okay, so let's now take a look at the fixed code. As you can see, we have our fake password here, and then we initialize a fake user, as you can see here. And what we do is this: we take a look at the database and search for the specified user. Okay, and if we found the user, we basically override our fake user, and if not, we don't. But the most key point thing is this: no matter what, if the user exists or doesn't exist, we still do our comparison. So no matter whether user exists or not, we still move to stage number 2. And no matter what, now once we run our script, we can see that the results are going to be similar to anyone, regardless if the user exists or not. So, oh, my bad. Let's do, where is our script? So I can do script.py and I should run it. So Python script.py. And now, as you can see, the timing is quite the same for all users, no matter whether the user exists or not. We always move to stage number 2, which is our bcrypt compare function. So take a look at the results again. The timing is quite similar for everyone. It might be a bit useful to speak about some hosting types. Let's say that now you've built your website or your API and you are looking to deploy it somewhere, then this lecture is the perfect one for you. Let's start with some 3 known hosting types. The first one is shared hosting. In shared hosting, you share the resources of the server with a couple of websites at the same time. It means that we have a specific server, and in this server we can host a couple of websites, and all of them will share the same resources and the same network capabilities. It means that if there is a certain website which gets a lot of traffic, for example, let's imagine that we have an e-commerce website which is quite popular, and now we have Black Friday, then this website can get a lot of traffic, which will impact other websites as well and will slow them down. That's why I wouldn't recommend shared hosting as your first priority, but it has its own advantages. such as being cheap. So you should consider whether you want it or not. When we are using VPS, which stands for Virtual Private Server, we are using a complete isolated virtual machine, which allows us to host our website without relying on other websites. In my opinion, this approach is much better than shared hosting because that you can have your own set of resources without anyone interrupting you. And to me, it seems a much better choice. If you are wondering how it works, basically all what is happening under the hood is this. They are taking one single server and then they divide it to a couple of virtual machines which are isolated. So each virtual machine is completely isolated from another. And then in each virtual machine, you can host your website or your API or whatever you want. And each virtual machine will have its own resources as well. Even though using VPS is quite more expensive than shared hosting, in my opinion, it is a much better choice. The third one is dedicated hosting. This one is much more expensive than the other two options. Here you are getting a complete physical server and in there you can host whatever you want. I think that it might be a better choice for enterprises and not for a single person who wants to host his website. And also on the other end, it is very expensive. So you should consider if you need it or not. Another option is to use cloud providers such as AWS and Google Cloud. Those providers offer you complete services for managing your websites and using orchestration tools such as Kubernetes. I do warn you, before interacting with such platforms, you should learn them well. There are a lot of people who didn't really know what they were doing, and then they were surprised to see that they got a very huge bill. Especially in cloud providers, before deploying your websites to them, make sure that you explore and learn enough and that you know what you are doing in order to prevent such mistakes.